Hello, am I audible?
Yes, you are.
Okay, fine, thanks. Yeah, so let me share my screen. Okay, so let me start with sequence. So can one of you tell me what is actually sequence? What is sequence?
It's a series of numbers that have like some relation to
Sorry?
It's a series of numbers, so like the set of natural numbers, like if you're going in ascending order from say 0 to 10, that would be a sequence. And something that converges into a sequence, 1 by n.
It doesn't, so it's not, this convergent is slightly different. Sequence has nothing to do with this convergent. Okay, so
can we define like this? A sequence is a function which is defined only at the natural numbers of input.
Yeah, that is actually the correct way of defining sequence. So sequence is nothing but it's a function from the setup. So since we are dealing with the real sequence, so sequence is nothing but it's a function from the set of all natural number to the set of all real number. Okay, so in some sense we have a list of numbers which are indexed by our natural number. So we have list of numbers a1, a2, a3, and so on. So as you can see, all these numbers, these are indexed by this natural numbers, right? So the sequence is nothing but it's a what it's a list of number which are indexed by natural numbers, or you can say that it's a function from the set of natural number to R. Okay, so this is what this is the definition of sequence. So now there are two things that can happen with a sequence. So first thing is basically the convergent sequence. So convergent sequence is basically means if you increase this index, so if you increase this index of the sequence, then it will come closer and closer to some fixed value, let's say. Okay, so then we will say that the sequence is a convergent sequence and the limit of the sequence is a. So what basically it means, if I increase this index, so maybe a3, a4, a5, and so on, if I keep increasing this index, then the term of the sequence will come closer and closer to a. Okay, in that case, I can say that my sequence is a convergent sequence. And when I don't have such scenario, in that case, I can say that my sequence is a divergent sequence, right? So there are two types of sequence. One is convergent and one is divergent. So can one of you tell me what is can one of you give me an example of a convergent sequence?
1 by x.
Sorry?
1 by x.
What is 1 by x? What is
Function.
Sorry?
If 1 by x is a function of x, sir.
No, so again, like the problem
1
is
by
like,
n, sir.
yeah, so you should not take a function like so it's better to write, since your function is from n natural number to r, it's instead of x, it's better to write 1 by n, right? Because 1 by x is something different. If I take this f of x equal to 1 by x, then in generally this basically means that this is a function from the set of all non-zero real number to r. But as you can see, I don't want this. I don't want all the non-zero real numbers, right? I want only the set of all natural numbers. So this is yeah. So this is a example of a convergent sequence, and as you can easily check that the limit of this sequence is nothing but 0. If I increase the value of n, then my sequence will come closer and closer to 0, right? So this is. So if I increase my n, then my sequence will come closer and closer to 0, right? And for example, you can also take it. So you can also get a example of a divergent sequence. Okay, so can one of you tell me example of a divergent sequence?
e to the power
n square.
n square, yeah.
Yeah, correct. N square, or maybe say e power n. Someone said e power n, or maybe you can take -1 power n as well. Okay, so these are the examples of divergent sequence, right? So basically there are two types of sequence, and within the sequence there are actually again there are few subcategories. So one is increasing sequence, right? And another one is decreasing sequence. So what is the definition of increasing sequence?
So a sequence which is tending to infinity.
No, that is not correct.
AN sequence to AN, A1 will be lesser than A2, and similarly like that.
Correct. So A1 is so lesser than equal to A2. A2 is lesser than equal to A3. A3 is lesser than equal to A4, and so on. So
can we say that increasing sequence will always be divergent?
No. Yeah. So basically, so in notation you can write it as an is less than or equal to
AN plus 1.
an plus 1. Okay, so this is the definition of increasing sequence, right? So for example, you can take this example. Let's say someone just said so let's say n, right? If my sequence an is equal to n, okay, so this is an increasing sequence, right? Because first I have 1, then I have 2, then I have 3, then I have 4, and so on, right? So as you can, once you keep going forward, then the terms of the sequence will keep increasing. Okay, so I have 1, 2, 3, 4, and so on. And for example, I can take, so this is an increasing sequence, and as well as this is a divergent sequence, right? So this is increasing as well as divergent. Okay. So but in general, it's not true. Like some increasing sequence, they can also be a convergent sequence. For example, you take this sequence, right? Let's say you take this to be minus 1 by n, right? Minus 1 by n. So if you see this sequence, this is an increasing sequence, right? So what is a1? A1 is -1, and this is less than or equal to -1 by 2. This is less than or equal to -1 by 3, right? And so on. So if you keep going in the right, then you can see that the terms of the sequence are increasing. So this is an increasing sequence, but this has a limit. So this is a convergent sequence, right? And what about the definition of decreasing sequence? Similarly, what you can say in case of decreasing sequence?
An is greater than or equal to
AN more than AN plus 1,
Correct.
or AN is less than AN minus 1.
Correct, absolutely correct. So when you have this scenario, in that case, you say that a sequence is a decreasing sequence. So for that, so the first term is always greater than or equal to the second. Okay, so in other words, I can write that an is greater than or equal to an plus 1. Okay, so example, similarly, can you give me few examples of decreasing sequence?
1 by n.
Correct. So you consider this sequence 1 by n. Okay, this is an example of a decreasing sequence, and as you can see, this sequence is a convergent sequence, and the limit of the sequence is nothing but it's 0, right? And any other example? So you basically given a decreasing sequence which has a limit. So can Can one of you provide me example of a decreasing sequence which don't have any limit?
-1 whole power n.
-1
Whole power n.
whole power. No, this is not a decreasing sequence, right?
Diverging, I think.
This is divergent. Okay, this is divergent, that is sure, but the problem is this is not a decreasing sequence. Okay, please mute yourself.
Sir, how -1 raised to n is divergent? Is convergent sequence? -1, 1,
Okay,
-1,
so
1.
okay, please mute yourself. I'm getting a lot of noise and I'm not able to hear you. Yeah, so yeah, you can ask your question. What you said?
-1 power n is convergent sequence. -1.
No, this is not convergent.
It will gives us -1, 1, -1, 1,
Yeah,
-1.
but yeah, so if you see actually what it will give you, -1, 1, -1, 1, and so if you increase the value of n, this sequence is not going to some fixed value, right? It's basically oscillating from -1 to 1, -1 to 1, -1 to 1. It's not going to a particular value, right?
Yes.
So then how come? So then certainly this is not.
Got it, sir.
Yeah. So
Sir, one thing I want to confirm that.
Just a minute, let me complete it. Okay, let me complete it. So this is not a convergent sequence, but again, I was trying to find a convergent decreasing sequence, sequence which is not convergent.
One by e to the power x.
-1.
So let me first tell you this. So clearly this is not decreasing, right? This so this you can see that this -1 is less than 1, right? So we need this condition to satisfy. Okay, so the previous term.
So 1 by e to the power x.
Sir, this sequence is neither increasing nor decreasing.
Correct. The sequence is neither increasing nor decreasing. Correct. Absolutely correct.
Oh, okay. Thank you.
Yeah. So yeah, any example?
1 by e to the power x.
-n.
Correct.
-n.
This is the, because see this is the increasing sequence. If you multiply some minus to this sequence, then basically you will get a decreasing sequence. So this is a decreasing sequence, and this is a divergent sequence. Okay, so let me take one more example. Okay, so you consider this example.
So basically, a convergent sequence means it has to tend to 0.
Sorry.
Basically, what is the convergent sequence means? Should it tend to 0?
No, it can have any limit. Okay, it's not that it will go towards 0. Okay, it can go to anything. So for example, you take this sequence 1 plus 1 by n. Okay, so this is a convergent sequence, and if you keep increasing your n, this all the terms of the sequence will come closer and closer to 1. Okay, so you consider this sequence a n. Okay, so what you can say about this sequence? Whether it's a decreasing sequence or it's an increasing sequence, or it's neither increasing nor decreasing.
It's converging to 0.
That I'm not asking. Sequence. I'm asking about whether it's a decreasing or increasing sequence. Forget about why.
Well, as the denominator keeps increasing, we are going to get lower and lower values.
But you have a minus sign, right?
Yeah, but it's.
But we will be moving towards to 0, sir.
Yeah, we'll be moving towards 0.
Yeah, so then
to 0 minus.
But you are moving in the negative axis, right?
Yeah, so it's increasing towards 0.
Yeah,
It is increasing toward minus infinity.
Not minus infinity, it is increasing towards 0.
0. Yeah, minus. Okay.
Got it, sir.
Right, so this again, like, see, the easiest way. So even if you have any confusion, you always try to check this. Okay, you take an, okay, and then you subtract with an plus 1. Okay, if this is greater than or equal to 0, okay, that basically means an is always greater than or equal to an plus 1. Okay, so from here you can say that the sequence is decreasing. Now, if an minus an plus 1 is less than 0, then from here you can get that an is less than an plus 1. So from here you can say that your sequence is increasing. So now you take this an. So this is your an, right? Minus 1, 6n minus 5, right? And you take your an plus 1. What is an plus 1? Minus 1 divided by 6 times n plus 1 minus 5, right? So now this is nothing but minus 1 divided by 6n plus 6 plus 1. So now you subtract. Now you subtract this an with n plus 1. Okay, and from here you check what is this thing. Okay, now from here you can easily check. Even if you have any confusion with the question, okay, you always try to solve in this.
So why this terminology increasing towards to 0? Can't we say tending towards to 0?
So again, like it's depend how you want to interpret. Okay, since we are actually we are talking about increasing and decreasing. That's why I use that term increasing towards 0. Okay, certainly this the limit of the sequence is 0. So you can use whatever you want. So it's depend what actually you are saying at that time. Okay.
But the sir, they are sounding same thing.
Yeah, they are sounding same thing, but this particular thing is saying something more. Okay, it's saying that the limit of the sequence is 0, and as well as it's saying that the sequence is also increased. Okay, so when you are saying the limit of the sequence is 0, then basically you are saying that the terms of the sequence are going towards 0. Okay, but you don't know whether it's increasing or decreasing. But when I'm saying this sequence is increasing towards 0, that means the sequence has a limit which is 0, and as well as the sequence is a increasing sequence. Okay.
But increasing if the slope will be positive.
Sorry.
If we talk about slope, then it will be positive.
I'm not talking about slope. Okay, so, and sequence don't have any slope. Okay, function has a slope.
Sir, in this you have said that an just do an minus an plus 1. Instead, can we substitute values for n as 1, 2, 3 and check it out whether it is the sequence is increasing or decreasing?
Yeah, that also you can do, but again, like
this notation,
yeah,
can you do that?
So that still there is some problem with that part also. Like so, if you suppose you see the thing is, suppose you have a sequence like this.
Yeah.
Let's say you have a sequence 1, 2. So this is your A1.
Okay.
This is your A2. Okay. This is your A3. Okay. Let's say again, this is your. You have a sequence like this, right?
Okay.
So if you just subtract A2 with A2 minus A1, okay, from here you are getting this is greater than 0, right?
Yes.
So from here you can say that, okay, by just checking these two terms, you can say that. So what you are getting, that the sequence is a increasing sequence, right?
Okay.
But this is not an increasing sequence, right? Because see, you try to go to this place. Okay.
Yeah,
so
1 minus 3 is negative.
So this is neither increasing nor decreasing, right?
Yes.
So if you pick some fixed term of the sequence, then you may get some wrong answer. Okay. So this an minus an plus 1, this actually ensure that you are checking for all the terms of the sequence.
Okay. Fine, sir.
Yes.
Thank you.
Yes.
It's a generalized thing, sir.
Yeah. Okay. So this is basically the sequence. Okay, let me solve.
So sir, here it is, we got the answer an minus an plus 1 equal to 0. So we have to decide it is increasing.
Where an minus
an plus 1, whatever these two value which we have talked.
No, this is not 0.
Okay, sorry. I have taken 6n plus 1 is 6n plus 5.
No,
sorry.
No.
Yeah.
That they are different. Yeah. Okay. Okay, so okay, so now you consider the sequence. Let's say consider the sequence AN divided by sin n times cos n. So any idea what will be the limit of the sequence?
So one thing I want to confirm that, can we apply L'Hopital rule in sequences?
No, you can't. So sequence is slightly different. L'Hopital rule you can apply to function, not to sequence. Okay, sequence is
This 2n plus 1
One,
is
one.
in square root or not?
sorry.
I think one is on.
Hello.
It's asking the first
One is
entirely.
square root.
First term is under root or not? One they're asking.
So,
Sin n
what
upon
is
n.
numerator?
One.
Could you do it?
Yeah. Yeah. Any idea how I should solve this question?
Yes, sir. First we should rationalize it.
Yeah.
Yeah. So I can rewrite this as so if I rationalize it, so I can what I will get 2n plus 1 minus 2n divided by divided by cos n times sin n, or maybe sin n times cos n, doesn't matter. Cos n times 1 by right. So this part is nothing, it's 1, so I can erase it. So this is my 1. So now can you tell me what will be the limit of the sequence?
Zero, sir.
Yeah, correct. 0. See, the thing is this part.
No, constant. Maybe don't know. It's by minus 1 to 1.
Yeah. So this part is actually it's between minus 1 to 1. Okay, it's a bounded part, and one more thing is that if you take your n towards let's say towards infinity, okay, this part will more or less will go towards infinity. So eventually all the things will go towards what?
Infinity.
0.
1 by infinity.
Yeah. Okay. So any questions?
No question, sir.
Okay. Sorry. I made a mistake.
Sir, here
Yes.
if we divide 2
No.
this root 2n plus 1 whole term by
No.
2n.
So okay, sorry. So what actually I wanted to write this times sin n
Question is
times
change.
cos n. Okay. So there is slightly okay. So in some sense there is slight problem with this argument. No, this may not happen. Okay. Let me change this question. Okay. So yeah. So basically I wanted to keep this product in the numerator. Okay, not in the denominator. So basically what I will do now, if I rationalize it, then I will get basically what? Sin n times cos n by 2n plus 1 2n, right? So now you can write, so you can write this an. So this sin n and cos n, they are always in between 1 to minus 1. Okay, similarly for cos n, right? So what I can write this? I can write this as sin n cos n. Okay, so whatever this an, let me write this as an. So an is nothing but it's less than 1 by right, and this is less than minus of right. Is it clear now why this
So
Yes, sir.
why, so how -1 and 1 comes in the picture?
because sin n is less than 1, right? Cos n is also less than 1, right? So if I take the product of sin n and cos n, so both the product will be also less than or equal to 1, right?
But sir, we'll never achieve -1 and 1 now, because when sin 90 is 1, cos 90 will be 0.
I don't care. I see, I may not achieve, but that is less than or equal to 1, right? That you agree on.
Yeah.
Yeah, so then I can write this, right? That is what I want. I don't want what they can achieve. So my first question is whether this condition is true or not. Okay, certainly this is less than or equal to 1. It doesn't matter if it is less than 1. I don't care that.
Okay.
So now what you can do, if you take your n towards infinity, right? If you take your n towards infinity, this will go towards 0, and as well as this will also go towards 0, right? So eventually this will go towards 0. Yeah.
Sir, this -1 less than or equal to sin n less than or equal to 1 is okay, but this cos n, this part I didn't understand, sir. It is -1 less than or equal to, because the numerator is sin n into cos n, no? So
yeah.
how did you get this this one, this inequality?
No, sir, that is what I have written, right? Your sin n, okay, is always greater than or equal to -1, right?
Correct. It is bounded between -1 and +1.
Yes. So cos n is also bounded.
It's also bounded between, yeah.
-1. Okay.
Okay.
So what will be the bound of cos n times sin n? That is what you want, right?
Okay, okay.
So this is certainly less than or equal to 1, right? Because the maximum value is 1
yes.
here, and the maximum value of 1 is also
okay.
yes.
Okay.
And when you, so what will be the minimum value?
-1.
Right. So when you can get the minimum value, so this minimum value -1 times the maximum value, so you'll get the lower bound.
Okay. Okay, sir.
Okay.
Thank you.
Sir, instead of doing all this, write in the starting if we multiply and divide by n, because we have a result that sin n by n tending to infinity gives us 0. So anything multiplied by 0 will give us 0. So in the very first step, if we multiply and divide by n, so as to get sin n by n.
If we multiply by n
and divide by n.
Yes.
So we will get sin n by n, and n tending to infinity, already we have a result that sin n by n gives us 0 when n tends to infinity. So
correct.
The whole term will become
so you want this also, you have to do the same thing with cos n, right?
Even if you don't do, because anything multiplied by 0 will give us 0.
See that is the problem. So you are making a mistake. So you are basically using this rule, right? Limit n tends to infinity. An times bn is limit n tends infinity an times, right?
Yes.
So this you can apply if the limit of both an and bn exist. Okay, so you don't know whether limit of all these things exist or not. Okay, first you need to prove that limit of all these things exist. Okay, then see, with that logic you can actually make any sequence. You can show that any sequence is basically converging to 0. Okay, if you, whatever you are saying, if you apply that. Okay, but that is not true, because see, the problem is if you this you can apply this if the limit of an and bn they exist. For example, if you take this sequence n square n, okay, you consider this sequence an equal to n, right? So now what I will do, I will take this, divide n square and multiply this n square, right? So then I can write this as 1 by n, n times n. Okay, and limit of this sequence is what? 0, right?
Yes.
then if whatever you said, if I apply that, then the limit of my sequence will be 0, right? But this sequence is a divergent sequence, right?
Okay.
So you can't apply. So the problem is, if you apply this rule, then limit n tends to infinity 1 by n times limit n tends to infinity n. See, this limit doesn't exist. Okay, so that's why this product rule will not work. Okay.
So how can we get in prior actually, like this if this property is there, like we can bifurcate the limits?
Sorry.
So how can we get to know like the limits are existing?
Yeah,
It will be...
that you need to check, right? So, or you need to guess in some sense. Yeah.
Sir, one thing, if you scroll down, I'm having a query here. -1 to 1, you have taken the equality signs as also, right, sir?
Sorry?
So suppose this question comes in exam, if we have the options where the two options are given, where we have -1 less than an and less than 1. Over is there also, and one second option we have less than and equal to also there. So which option would be correct, sir?
Both the options are correct.
So this is what I'm querying, sir. But sine and cosine both should not be like, we can't achieve -1 and 1, right, sir? It should be less.
That depends on the domain of sin x and cos x. Right now, you are actually varying this n over natural number. Okay, so when you will vary over natural number, then certainly you can't achieve -1 and 1. Okay, but if you vary over real number, then certainly you can achieve. And there is no problem if I write less than or equal to. Basically, what is less? So I'm including both the thing. I'm including less than, and also I'm including equal. Okay.
Okay.
Yeah. Okay. So let's next.
So one thing, in earlier case, we had a mistake in while asking the questions where you had written sine and cosines on the bottom denominator, right, sir?
Yeah.
So in that case, we can't say sine and cosines will be like -1 to 1, as we discussed. It is bounded. So
no. There is a
indeterminate form, right? So 0 into infinity it will be formed.
So the problem actually, okay, so there is some problem with that argument, because the sin x actually can go to 0, right?
Yeah,
it can be very
Hmm.
close to 0. Okay, so when that will happen actually so for that part actually you need to do it very carefully. Okay, so probably you need to give some other argument. Okay, so whatever argument actually I said it initially, that is completely incorrect. Okay.
Yes. Okay.
So can
Hello.
am I audible?
Yes.
Yeah. So can you give another example like this? If possible.
What do you mean by another example like this? Like, okay, so
You want some more question?
Yeah.
Based on sequence, I think.
I think sandwich theorem based, like one more question.
So this is the sandwich theorem, right? I have applied this sandwich theorem, right? So
Yes.
So can we apply it without sandwich theorem?
Yes, so how can we solve it without using the sandwich theorem?
Because it taking long.
You
process.
don't see for your for your convenience. Actually, I have used the sandwich theorem. You don't have to use actually sandwich theorem. It's pretty clear. This part is bounded, and
Yes.
you have a big number in the denominator, so it will definitely converge to 0.
Yes.
Yeah. So so again, like if I but in some sense sandwich theorem, let's say you consider this example. What example I can take? Again, like basically you have to use again same kind of argument. Like if you take, so suppose you have a sequence like this an, which is, let's say 1 by n cos 1 by n square, right? What will be the limit of the sequence?
Zero.
0.
Again, again the same argument, right?
Yes.
So yeah. So hello, yeah. So for example, even you probably you need the same sandwich theorem to show that this sequence is also 0. This sin n by n, right? You can use the sandwich theorem to show that this sequence, the limit of this sequence is also 0. So this is precisely 1 by n, and it's greater than minus 1 by n, right? So say similar kind of example you can create on your own. Okay, so the vague idea is like this. Okay, so you need to show that this is less than something and this is greater than something. Okay, and also you have to choose these two things carefully so that the limit of this one and limit of this one are same. Okay, then only you can apply the sandwich theorem. See, if the limit of this one is maybe, say, let's say this is k and this is some k plus 1, then you can't conclude anything. Okay, so you have to choose this below part and the above part so that the limit of both the parts are same. Okay, so so now let's move to limit of a function. Okay, so what are the things that that one needs to check to find out the limit of to say that the limit of a function at a particular point exists?
First, we can factorize it and
Or if it is continuous.
Yes.
Left-hand limit and right-hand limit has to be equal.
Yes, correct. So okay, so again, like you are, yeah. So whatever that Sayan actually said, it's correct. So to take a limit of a to say actually whether the limit of a function at a particular point exists or not, so you need to check two things, right? You need to check two things. First you need to find the left-hand limit and right-hand limit, and then you need to check whether the left-hand limit and right-hand limit are equal or not. Okay, so suppose you have a function. Okay, suppose you have a function. Let's say your function is, let's say, R2R. So you want to check the limit. Check the limit of this function at, let's say, A. Okay, you want to check whether the limit of this function exists at A or not. So first what you need to do, you need to find the left-hand limit, right? The left-hand, let's say this
LHS.
Left-hand limit. So this left-hand limit you need to find, and this basically you denote this as x tends to a minus f of x. Okay, and next what you need to do, you need to find the right-hand limit, right? That is
x tends to a plus a of f of x.
Yeah, so this is, again, this is not a notation. It has some meaning. So there is a meaning of this a plus and this a minus. So when I'm saying that this is a minus, that means I'm coming to this point A, okay, from the left hand side of A, right? From the left hand side of A. And when I'm writing this as a plus, okay, when I'm writing this as a plus, I'm basically coming to this a plus from the right hand side of A. Okay, so that's why I'm writing this as a plus, and that's why I'm writing this as a minus. So two things I need to check. I need to first find this left hand limit and right hand limit. So from now I can say that whether if this left hand limit and right hand limit are equal, okay, if these two things are equal, then I say that limit exists, right? And if they are not equal, then I say that this limit at the point A doesn't exist. Is it clear?
Yes, sir.
Yeah. So
yes, sir.
Okay, so now let's solve few questions.
Just sorry, could you just repeat what is the point when you say it doesn't exist? I just missed it.
If the left hand limit and right hand limit, they are not equal.
Okay, thank you.
If they are not equal, then you say that not exist.
Or may not be finite also, means if both tends to infinity, then also limit not.
Yes, so correct in some sense, yeah. So yeah, probably yeah. One should mention it separately. But again, like so from here actually. So when you are saying that limit is going to infinity, okay. So from here itself actually you can say that the limit doesn't exist because this IL itself doesn't exist. Okay. And if this is infinite, then you can say that this IR itself doesn't exist. Okay. So from there itself you can say that this limit doesn't exist. See one of the left. See if one of them is infinity, that is if one of them is left hand limit, and please mute yourself. So see if one of them is infinity or minus infinity, then from there itself you can say that the limit of the function at that point doesn't exist. Okay. And
Sir, do you mean that if limit extends to infinity, then it does not exist?
no.
Yes, sir.
No. That
Sir,
is.
but how can that be possible?
Okay, let me. No, I was not saying that. Okay, what I am saying, as x tends to a, this IL is infinity, or maybe say minus infinity, right? This IR is plus infinity or minus it. In these cases, okay. In these cases also, I can say that limit at.
Okay, I got it.
No, so I'm not taking that x tends to infinity. That is. So I'm just taking that x is going towards a minus, and here I'm taking that x is going towards a plus. Okay. So
overall the point is, if right hand limits and left hand limits are tending to infinity, if one of them is tending to infinity, so there is no existence of the limit, right, sir?
Correct. Okay, any confusion with the definition?
Sir, can you please explain me when the case when limit exists but the function is not continuous?
Okay, when limit exists, what do you
and
mean by
function is discontinuous?
Okay, I'll come to that. Okay, so if that let me come to that continuity, but I'll come to that. Don't. So the continuity, you just need one more thing, right? What you need for continuity? What you need for continuity?
So both
value.
the limit values has to be equal to the function value at that point.
Yes. So you need one more condition for continuity. Okay. So that condition is if this left hand limit is same as right hand limit is same as
function
the value of the function at point, then from here you can say that f is
continuous
at x equal to a. Okay, so this is the extra condition you need. Okay, so first let me try to do
limit.
Do the limit. Okay, so any specific example you want me to discuss, or I can pick on my own?
Sir, I have a question. I mean, I have an example.
Yes.
So, sir, it's f of x is equal to
sorry,
mod
f of x. F of x.
Fx is equals to mod x square minus 4x
x square minus 4x
plus 3 whole divided by x minus 3.
X minus 3.
Yeah. And the condition is x not equals to 3.
Yeah, certainly. And if x is 3, then it's 0, right?
So it's given 2 actually.
It's 2. Okay, no problem. Okay, so Sayan, I'll come to this question. So before that, I actually want to solve some easy question. Okay, it's
okay.
It's not difficult, but again, it's not so easy. Okay, so I don't want to jump to this.
Okay, sir. The reason yes, sir, I totally understand. I actually said this expression because I have a question. I mean, whenever like the discussion is over, I would like to ask about it. Not now. That's why I said it. Actually.
Yeah. I'll discuss now itself. But okay, before that, let me. Yeah.
Sir, can you hear me?
Yes, I can hear.
Sir, can you please explain the infinity part that you explained for the previous question again once more? Sorry, I did not get that.
Sorry, which one?
The infinity part, when x tends to infinity, you were explaining, it still has a limit.
No. That is no. I am so nowhere I said that x is going towards infinity. Okay, so x is going towards a negative and a positive. That is what I said. Okay, so when see the thing is okay. So you consider this function, right? You consider this function 1 by x, right? So when x is going towards this 0 plus, right? When x is going towards this 0 plus, now you consider this function. Okay. Okay, let me I have a example to discuss. Okay. Now you consider this function f of x, which is 1 by ax. If x is not equal to 0, okay, and it is 0 if x is equals to 0, right? This is my function, and this function is basically from R to R, right? So this is a function. So what I want to know, I want to find the limit of this function at x equal to 0. I want to know whether the limit of this function at x equal to 0 exists or not. That is my aim, right? So first what I need to do, I need to find the left hand limit, right? Left hand limit, right? This is my I L. Okay. So what is the left hand limit? What is the left hand limit of this function?
0.
Why?
Infinity.
Minus
Because
infinity.
when x is
Minus infinity.
Minus infinity.
Yeah, answer is basically minus infinity. So it's certainly it's not 0. See again, like try to understand the definition. Okay. So what actually again? So that's why I said this 0 minus has some meaning, 0 plus has some meaning, right? So what? So you have 0 here, right? You have 0 here, and you are coming to 0 from this side. You are coming to 0 from this side. So since you are coming to 0 from the left hand side of 0, that means this is whatever number you are taking, all are negative, right? And also they are very small, right? Because they are very much close to 0, right? So when you have a negative number and that is very much close to 0, then 1 by x, right? 1 by x is negative and as well as very large in the sense of magnitude, right? So then 1 by x will go towards what? Minus infinity, right? Any problem with this one? Clear why 1 by x is going towards minus infinity?
Yes, sir.
Yeah. So that's why this as x so as x tends to 0 minus, the value of the function will go towards minus infinity, right? So this is minus infinity, right? So from here itself, I can say that since this is minus infinity, I can say that my left hand limit itself doesn't exist, right? So then further I don't have to go and talk about the limit. Since the left hand limit itself doesn't exist, from here itself I can say that my limit doesn't exist. Okay. And also like you can also check, similarly you can check the right hand limit as well. Okay. So from even if you check the right hand limit also, you'll get a similar kind of answer. Okay. So now you check the right hand limit. What will be the right hand limit of this function? Right?
Positive infinity.
Correct. Absolutely correct. You will get positive. So in that case also, since you are getting some infinity, see, infinity is not a real number. Okay. So then this from here itself you can say that right hand limit doesn't exist, and since right hand limit doesn't exist, from there itself you can say that limit doesn't exist. You don't have to check both the right hand limit and left hand limit to tell that the limit doesn't exist. Once you know the left hand limit doesn't exist, from there itself you can say that limit doesn't exist. And if you suppose someone is taking this right hand limit, from here itself also you can say that the limit doesn't exist. Okay, you don't have to go further. Okay, so So this is a question. So I'll come to the Sion question, but before that, let me take this question. Probably this question is in your activity question. It's basically your activity question. So you take this function. Okay. So let's say if x is, let's say, greater than or equal to 10. Okay, and it's maybe say it's 5 if it is less than 10, right? So again, I want to know, I want to find the limit of the function at x equal to 10, right? I want to find the limit of
exist.
Okay, yeah, so you are correct. Okay, so but we should go by step by step. So first, what we need to find? We need to find the left hand limit, right? What will be the left hand limit of this function at x equal to 10?
10.
5.
5.
5.
5.
5.
Correct.
Right?
5. Yeah.
Because when you are coming to 10 from its left, actually the value of the function are precisely 5. So that's why the limit is 5. And what about the right hand limit?
10.
X.
10.
That will be 10.
Yes, correct. 10, right? So as you can see here, in this case, both left hand limit exist, both right hand limit exist, right? But they are not equal, right? So left hand limit is not equal to the right hand limit. So that's why in this case also limit doesn't exist, right? So yeah. So and also you can have one more case for which limit will exist. Okay, you can take any function. Let's say f of x equal to x. So if you take, let's say, f of x equal to x square, right? You say x square, right? Now if you check limit at any point, let's say you pick 2, right? At x equal to 2, if you check the limit, what will be the left hand limit?
4.
4. And what will be the right hand limit?
4.
4.
So left hand limit and right hand limit are equal. So that's why this function has a limit at x equal to 2. And you can go slightly further. Actually, this left hand limit and right hand limit, they are equal, and they are also equals to this f of 2, right?
Yes,
so
sir.
So you can say that this function is continuous at x equal to 2. Okay. And there is nothing special about this point 2. Okay, you can pick any point. Okay, and someone said that for polynomials, yeah, because polynomials are actually continuous functions. That's why you can so in that case, always you will get a limit, and that limit is precisely the value of the polynomial at that. So what was the question? F of x equal to x square minus 4x plus 3.
Sir?
Yes.
Sir, why fx where limit extends to 10 minus y it goes to 5?
Can
Constant.
you draw the graph of this function?
Yeah, 5 till.
No,
5.
I'm not asking to you, whoever asked this question. Yeah. So just allow her to answer this question. Yeah, what will be the graph of this function? Let's say this is my 10.
It goes to 10.
Sorry?
So it goes to 10 from negative side.
No, I'm asking about the graph. Okay. What will be the graph? Okay, so again, like if you see this, if x is greater than or equal to 10, the value of the function is what? x, right?
Yeah.
The
Yeah.
value of the function is x. So then in that case, you will have a line like this. Okay, this line actually, if you extend this line, it will pass through origin. Okay, so this is your line, but I can't extend this line below of this point 10, because this condition holds if x is greater than 10, and if x is less than 10, the value of the function is precisely 5. Let's say this is 5 and this is 10. So in that case, I'll have a
y equals to 5.
right, and this point is not included. Okay, this point is not included. This point is not included. Now, if you go towards 10, okay, if you go towards 10 from the negative side, right?
Yes, sir.
Then where this value of this function will come? It's precisely 5, right? So all the points, the value of the function is 5. Okay.
Okay. Sir.
Yeah.
Got it.
Okay, so let me come to this point. F of x equal to x square minus 4x plus 3. F of x equal to x square minus 4x plus 3 divided by x minus 3, right? And what is the other value? It's 2.
2, sir.
Yeah. So this is the case if x is not equal to 3, right? And this is the case.
Yes, sir. And 2 when it's equal to 3.
If x is, it's 2 if x is equal to 3, right? So 3 square 9. Okay, so clearly this has a root. So okay, so we need to rewrite this thing. So what is the factorization of
x minus 1
x minus 3 into x minus 1.
X minus 1, x minus 3.
right? So this is whatever it is. This is my function. I can rewrite my function in this. Okay. So what I want to find the limit of this function at x equal to 3, right? And also we can check the continuity as well. Okay. So first tell me what will be the left hand limit of this function.
Sir, it will be somewhat negative, I think.
It would be minus
So mod
something.
will open with minus negative sign.
Sorry?
So minus bracket x minus 3.
Minus 2
bracket
minus
Tending to minus 3.
Minus mod x minus 1.
It's basically tending to minus 2. Okay.
Minus
2. Right. See the problem. Okay, so this part is not a problem, right? This part is not a problem, right? Because when x is going towards so when x is going towards minus 3 minus, okay, from the left hand side of 3, then this part certainly x minus modulus will go towards what? 2.
Positive value.
2, right?
That will be 2.
Sir, consider whole
Left
function.
hand will be minus 2 and right hand will be positive 2.
Yeah, just give me a minute. Let me solve the question and you can ask if you have. So the remaining part is basically what? X minus 3 minus x minus 3 modulus. The only problematic part is this one, right?
Sir, if you consider whole function, it will be easier, sir.
No, it won't be easier. Okay, so so the thing is, yeah. So now if you see this thing, so what basically? Okay, so again, you are basically in this case, and which I have said maybe more than 10 times. Okay, if not in this session, but yeah. So mod of x is x if x is greater than equal to 0, and it is minus x if x is
when it says 0.
less than 0, right? So when actually you are coming to this 3, when you are coming to this 3 from the left hand side, right? So in that case, x minus 3 is what? X minus 3 is negative, right? Correct?
Negative.
Negative. So in that case, what I can write? I can write this as minus of x minus 3 divided by x minus 3, right? So what I'm getting here? Minus 1. Okay. So the limit of this part is what? Minus 1, right? And the limit of this part is what? 2, right? So eventually what I will get? The left hand limit is
minus 2.
Minus 2. Yeah, correct. Minus 2. Sorry. My bad. It should be minus 2, right? Okay, please mute yourself. And similarly, I guess now you can easily compute the right hand limit as well. What will be the right hand limit?
Plus 2.
Plus 2.
It will be 2, sir.
Yeah, plus 2. Yeah, correct. So what will happen here? So when you take this x minus 3 by x minus 3, and when you are taking x goes to 3 plus, so in this case, when you are taking x to be 3 plus, your x is always greater than or equal to 3, right? That means x minus 3 is always greater than or equal to 0. That means modulus of x minus 3 is nothing but x minus 3. I basically am using this. So in that case, what I can write? This I can write is x minus 3 divided by x minus 3, which is 1, right? And this part, for this part, I am getting 1, and for this part, I am getting 2, right? So for the whole part, I'll get 2, right? So my left hand limit is minus 2, and my right hand limit is 2. Clear? So that means the left hand limit is not equal to right hand limit, and that means the function has no limit at x equal to 2. Okay. And also,
can you explain again that the x minus 1 part, how it was to?
So when the limit does not exist, can we say it is not continuous?
Yeah, that is yes, sure. If limit doesn't exist, then see. So first, actually, you have to. So when I defined this continuity, so this part, if so to come to this part, okay. So limit doesn't exist means this part itself doesn't hold, right? So if this part doesn't hold, then from there itself you can say that f is not continuous at that point. Okay. Yeah. So any question from
No,
here? Yeah. Fine. Okay.
Sir, in the mock, this thing, there was also the differential, like the derivative of this. So like when we get there, can we also do the derivative of this function?
Where you want to differentiate this?
Like once you've done differentiation in the session, can we just differentiate this function once?
Why I need to differentiate this function? This function has no limit at x equal to 3, right? So if you want to differentiate in some other point, then certainly you can. But if you want to differentiate this function at x equal to 3, then this function is not differentiable at x equal to 3.
At any other point, like
there is nothing.
Say x equal to 1 or something.
That is pretty easy, right? At x equal to 1, this is more or less, this is a polynomial, right?
Differentiable.
Yeah.
Okay, got it. So the modulus sign, like it will just become a positive function and you can derive it.
Yeah.
Okay, got it. Fine.
So the only problematic part is this one, x equal to 3. And at this point, this function is undoubtedly is not.
It's not continuous itself.
Yes,
so
yes.
Got it.
Okay. Just let me think. Oh no. Probably I have said something wrong.
Sir.
Okay, so when I said that this function is differentiable at all the other points, that is incorrect. So probably you should check at one more point as well. That point is 1. Okay. So I'll come to that point. Okay, so this function most likely it is not differentiable at x equal to 1 as well. Okay.
Sir, that is my question. I mean, that is exactly what my question was. That's why I said this.
Sir, excuse me, sir.
Just yeah, tell.
Sir, if you consider the numerator as a whole function and do, it will be easier, sir. If from the function we can say if x is between 1 and 2, then the numerator part will be negative.
Okay, so and again, if you think that is easier, you can try that in that method as well.
Sir, it is easier and we will get the answer.
Yeah, probably. I still I don't understand what you are saying, but you can try that method as well. Okay. Again, so the main problem is I can't explain in multiple methods. Okay, there are so many things left which I have to cover. Okay.
Sir, for practice, sir, I was saying maybe we can pick up quiz 2 for questions, and if you can help us just discuss.
Yeah, that is what I'm saying. So you can ask. Look, so when I'm covering this thing, right? So I have asked you if you have any question on limits. So you can pick the limit question from quiz 2 and you can ask here, right? I'm asking whenever I'm. So I in the beginning I asked you, right? Do you have any specific question related to limit which you want me to discuss? That I asked you, right?
Yes, sir. Yes, sir. Sir, we are opening, sir. Just.
Yeah, certainly now I can't solve more questions on limit. Okay, so that is probably you can ask some question related to continuity, right?
Sir, I have a doubt. May I ask?
No, if you have doubt, then I'll take in the name.
Sure.
Is there any doubt related to this thing? Whatever
yes, yes, sir. It is from week 8.
Activity question or maybe some graded assignment.
Graded
right?
assignment.
Yeah, I'll come later.
Okay, sir.
Yeah. Okay, so the continuity, as I said, it's basically some you need to go one more step. Okay, so you basically need to check if the limit exists. Okay, if the limit exists, if limit doesn't exist, then from there itself you can say that the function is not continuous. If limit exists, then you need to check this condition. Okay, you need to check this condition. Okay, you need to check that both the limits, if both the limits are equal to the functional value at that point, then from there you can say that the function is continuous at x equal to a. If both the limits are not equal to f of a, okay, in that case you can say that your function is not continuous. Okay, any questions? Since someone said any question related to continuity which you want me to discuss now?
Sir, I have a question from quiz 2, sir.
Yeah, please tell me.
F of x is equal to 1 by f of x is equal to 1 by e power 1 by x plus 1.
E power
1 by x plus 1.
Okay, I have discussed it maybe 10 times. Okay, I'm not going to discuss it. I basically have discussed this question in quiz 2 revision session.
Okay.
So the same question actually it was in your quiz 2 paper. Any other thing? Okay.
F of
So can we jump onto the week 10-11?
Week 10-11? No, we are not. No, this is basically for calculus part. Okay, week 10 and 11 there is one more session. Okay, so it's not possible.
Sir, if there is a derivative question, will you take it now or later?
After
continuity.
Yeah.
Okay, fine. Okay, sir, thank you.
Okay, let me take. I don't know whether I have discussed it previously or not.
Can I tell, sir?
Yeah, so you need to check the continuity of the function at x equal to 0. Okay, you need to check the continuity of the function at x equal to 0. So you need to check whether this function is continuous at x equal to 0 or not. Tell me what I should do. First, what I need to find.
Take the left hand and right hand limits.
Correct. First, I need to find the left hand limit. Okay, so what is the left hand limit? Limit x tends to just a minute.
0 minus.
Yeah, so
Minus x.
What is that? Limit x tends to 0 minus x square by
minus
mod of x is precisely minus x.
Minus x.
Absolutely correct. So this is what?
Minus x.
This is minus x. So what is this final result?
0.
Yes. And similarly, if I take the right hand limit,
positive x.
So that is also 0.
Yes. So this will be final result will be x. This is 0, right? So now the left hand limit and right hand limit, they are same, right?
Yes, sir.
So now from now can I say that this function is continuous? Please mute yourself.
Yes, sir, we can see.
Yes, sir.
No, limit is x.
Only if the value.
We need to find f of 0.
Yes, we need to check. Actually it's given. So we need to check one more condition, whether these two things are equals to f of 0 or not. Okay, so for that I need to check what is the value of function at x equal to 0. The value of the function is what? It's 0, right? So now I'm sure that this left hand and right hand limit are same, and they're precisely same as the value of the function. Okay, so after checking this step, I can say that f is continuous at x equal to 0, right? Okay, so
yes, sir.
Yeah. Okay, so
one question. Sorry. Is continuous and not differentiable mean the same thing?
No.
Can you please explain the difference?
For that, I have to come to differentiability.
Okay,
so when I'll come to differentiability, please ask this question. Whatever you ask now.
Sure,
once I cover, just remind.
Sure, sir.
Yes.
Sir, I have a question. So when you do the left hand limit as x tends to 0 minus, will this not become 0 by 0?
Which one?
X square by modulus of x. Will this not become 0 by 0?
Yeah, this becomes 0 by 0 if you are taking this denominator and numerator separately. But the one good thing is actually I can cancel.
Okay, oh yeah, okay.
So when you have something like this x by sine x, right? Okay, so you can't. So here you have 0 by 0, right? But you can't cancel this x with this sine x, right? But when you are x square divided by minus x, right? This is also 0 by 0 form, right? But I can cancel this x with this x square, and I can get x in the numerator, right? So that is the advantage here we are certainly in 0 by 0 form. Okay, but still some part of this denominator is actually is basically common with the some part of this numerator. Okay, that's why we can cancel it.
Okay, so in effect it's like you cancel one x in this case, and you ignore the modulus, so it's like because it becomes 0, it's
0.
So
because we can ignore the modulus when actually we are talking about this 0 minus and 0 plus.
Correct. Yeah. Okay, sure. Thank you.
Yes.
But if the value is not equal to 0, then this function could not be continuous.
No. Suppose I change this value. Suppose at x equal to 0, my value of the function is, let's say, 5.
No. This x is not. Suppose
x equal to 0, so x equal to 1 or x is not equal to 1.
So the only problem here is actually this at x equal to 0. See if x is not equal to 1. Sorry, if x is not equal to 0.
Not equal to 1.
Not 1. You want to say x not equal to 0.
No, yeah, this question is okay. Like I know this question is I'm asking in the question if this is f of x is equals to x square by mod of x. If x is equal, if it's not equal to 0. So other than 0, if x is not equal to 1 or 2 like that, then LHR or RHR equal to minus x and x. So minus 1 and 1, that will be the answer. So in that case, this function could not be continuous.
No, you define your function. Can you define your function again? F of x is what?
X square divided by mod x.
Mod x.
If x is not equal to 1.
If x is not equal to
1.
Yes, correct.
And then is 0 or 0 if x is equal to 1.
X equal to 1. So, okay. So before that, let me ask you one question. What is the domain of this function?
Domain of this function is like
infinity.
Sorry? What is the domain of this function?
The input values could be the
no, I'm asking
minus infinity to plus
value, real number.
So you are saying the domain of the function is what? R, real number.
Yes.
So can you tell me what is the value of this function at x equal to 0?
That is not defined.
That is not defined, but you are saying, right, the domain of the function is R. So that means R. So 0 is inside R.
Inside. Yeah. 0,
then,
no. 0 is not inside. 0, R minus 0.
Yeah.
At 0, it is 0.
At 0, it's not 0. You have not defined the value of the function at x equal to 0.
No,
so
you defined if x is not equal to 1,
so
that
here,
is 0, right?
Here, sir, I'm just asking the LHR equal to the RHL of x square divided by mod x. Then in this equation, our answer is minus x for the LHL and the plus x for the RHL. So the minus x answer will be minus 1 and the plus
okay,
x.
So check that. You check that the left hand limit is 1. The right hand limit is 1 at x equal to 1. That you need to check. That is not difficult. At left hand limit is 1, right hand limit is 1, and they are equal, right? Left hand limit is equals to right hand limit. That means, so again, this function is from R minus 0 to R. This function is not defined at 0. Okay, if you want to define it, then you have to specify some value at x equal to 0, and you have not done that. So the left hand limit and right hand limit, they are precisely 1. Okay, and so from here you can say that the limit of this function at x equal to 1 exists. That you can say. Okay, but this function is not continuous because this left hand limit and right hand limit is not equal to f of 1, which is 0. Okay. So yeah, so it's pretty easy.
Sir, how is left hand limit is equal to 1 is equal to right hand limit?
You try to check it. I have basically the same whatever method I have explained here, the same thing you can do it here. Okay. So when
will
actually
it not be minus 1 and 1, sir?
So when you have 1, right? When you have 1, okay. So when you are coming to 1, okay, when you are very close to 1 from its left hand side, okay, x is positive, right? X is positive
only
or
if
not?
it is in the range 0 to 1, right?
And when you are coming to 1 from its right hand side, okay, very close to 1, and you are coming from its right hand side, in that case also
X is 1.
Positive. In both the cases, actually x is positive.
Okay.
Right? So modulus of x is nothing but x. Okay. So in that case, basically your f of x in this small neighborhood of 1, this f of x is precisely x.
X, okay.
Okay. Okay, so so let me move to differentiability. Okay. Okay, can one of you tell me what is the definition of differentiability?
Limit h tends to 0, f of a plus h minus f of a divided by h.
Yeah, so before that, tell me, you have a function, right? F is a function.
Yes, I have a function f x.
Let's say
R to R.
R. So you where you want to check the differentiability? You want to check at which point?
You want to check it at a point on that function, and you want to check the slope at that instant at that point.
So suppose you want to check the you want to check whether this function is differentiable at x equal to a or not, right? That is what you want to check. So for that, what you need to check?
Left hand derivative and right hand derivative.
Continuous or not at that particular point.
Yeah, you are basically, you tell me the definition, like you are giving one more definition for this definition. I'm asking the precise definition in terms of this limit.
Yeah, it was
Limit h tending to 0.
The limit of x tending to a. H tending x tending to
Tends
a.
to 0.
H tending to 0. F of a plus h.
Minus f of
F
of a by h.
By h.
Okay. So if this limit exists, okay,
it is differentiable.
then you say that the function is differentiable. Just a minute, let me complete. Okay, so if this limit exists, then I say that my function f is differentiable at x equal to a. Okay, if this limit exists, if this limit doesn't exist, then you say that your function is not differentiable at that point. Any doubt? Now you ask.
Sir, this x should be a, sir.
Yeah, correct. Absolutely correct. You are absolutely correct. Yeah, correct. Thanks. Okay, no problem with the definition. Okay, any specific example you want me to discuss to check the differentiability of that function?
Sir, the previous thing that you said, like we have to check at x equals to a 1 point. Can you check that?
Function, quadratic.
That mod.
Which
sir,
one?
The mod function. Sir, the mod function that you said, like we need to check for x equals to 1 as well. Can you do that? I mean, since we are in differentiability.
Yeah, I'll come to that, Saran. Just first, let me go with yeah, it's fine. Like, thanks, you have reminded me. But before that, I want to start with the easy one. Okay.
Mod x only we can start.
Okay, mod x. Okay, so let me start with f of x equal to mod x. So okay, so where you want me to check the differentiability of this function? At which point?
At 1.
0.
Okay. Please mute yourself.
So can you hear me?
Yeah, I can hear you.
Sir, sorry. In the definition you have mentioned, when h tends to a 0, just possible to say why we use h tends to 0. I know that is the small differentiable part for which we are trying to find the value. So, but why does it have to tend to 0?
Okay, before that, have you attended any previous session?
I have gone through the videos, sir.
Okay, so the thing is, okay, so basically it's more or less what
H
it's
is the delta.
Yeah, so first for that, actually what you need to understand the meaning of this thing. Okay, first you need to understand the meaning of this thing. Okay, so suppose you have a graph, you have a function. Okay, let's say you have a function like this, right? So what actually you want? So what is the main idea of derivative? So suppose you have a point A, right? You have a point A, right? So here you have A, so this is A, and this is, let's say this point is A comma F of. So the idea is basically you want to know the tangent, the slope of this tangent line at this point. Okay, so that is the main idea of derivative. That is what you want to compute, right?
Yes, sir.
So what you do is, so what now you can do? So now you can take bunch of different line, right? You take A plus H, right? So this is A plus H, right? A plus H. If this is my A plus S, and then what will be the coordinates of this point? This is
A plus H comma F of A plus H.
F of A plus H, right? So now what I will do now, I'll take this line. Okay, right? What is the slope of this line? This blue line. What is the slope of this blue line? This is precise. This is precisely this, right?
Right.
Yes, sir.
This is precisely this. So now when this h, so when you bring this h towards 0, right? That means this A plus h is precisely coming to this point A, right?
Right.
So in that case, this blue line, so this blue line, if you see this blue line, it will come closer and closer to this red line, right? So when h tends to 0, it will come closer and closer to. So when h tends to 0, that means this whole thing will give you the tangent of this red line.
Correct.
Does it make any sense? Whoever asked this question.
Yes, sir. It makes sense.
Yeah, fine. Anything else you want?
Sir,
Thank you.
Yeah.
Sir, if you don't mind, sir, one thing I wanted to just say, sir. So, sir, this concept actually is very well covered in our videos. So actually, if we keep going back to the basics, sir, other people will. So
no, I didn't spend much time on this. Okay, so
okay.
It's fine. Yeah.
Sure.
So yeah. So okay. So the thing is, I want to check whether this function is differentiable at x equal to 0 or not. So for that, what I need to check. So this x equal to 0, that is means this is my A. Okay. So if you just go and see the definition, this point A is basically 0. So that means what I need to check whether this f of A, which is 0 plus h minus f of 0 by h, right? And this is nothing but 0. This is modulus of h by h. So what is this limit? What is this limit? Now you should able to answer this question. Oh.
So 1.
Again, you are making the same mistake.
Left hand limit is -1, right hand limit.
Left and right limits are different.
Yes.
-1.
Yeah.
-1 and 1.
So this is exercise you compute. So if you see this left hand limit is -1, and the right hand limit is +1. Okay. So in other words, these two things are different, right? Since these two things are different, then I say that my function, whatever this function is, modulus of x, this is not differentiable at x equal to 0. Okay. And actually you can check that at any other point this function is always differentiable. For example, let's pick x equal to 1, then what you will get? F of 1 limit. Okay, let me do it quickly. 1 plus h minus f of 1 by h, and this is limit. Okay, yeah, this limit s tends to 0, 1 plus h minus 1, correct? And this is h, okay, and so you can compute that the right hand limit is basically 1 and the left hand limit
Will also be 1.
1. Okay, because when h is going towards 0 negative, 1 plus h is actually greater than or equal to 0, because h is very much close to 0. That means 1 plus h is always greater than, will be greater than or equal to 0. And also when you are taking h to be 0 plus, in that case also 1 plus h. So this is precisely 1 plus h is nothing but, it's basically 1 plus h modulus is nothing but 1 plus h. Okay. Any doubt?
Yes, sir. So
Yes.
this much is clear. So just if for a well-defined function, can we actually test with the actual value of h, taking a very small number? Can we actually test the left hand and right hand limit by taking a very small value of h, say 10 to the power minus 5, something like that?
Yeah, but again, like, so you are actually taking a particular sequence of number. Okay, so when I'm saying actually this limit exists, then actually it should give you the same thing for all the possible types of sequence of numbers.
Okay.
So when you are actually checking for a particular number, from there maybe you may get a value. Okay, but from that value you can't conclude anything. Okay, so you need to consider all the possible type of sequence which are converging to 0 from the left hand side, and all the possible types of sequence which are converging to 0 from the right hand side. Okay.
Thank you, sir.
Yeah. Okay, so
sir, would you like to answer the question about difference between not continuous and not differentiable now?
Yeah. So can you repeat your question?
Sir, I understand if the left hand side limit and right hand limit is not equal, then it is not continuous, and similarly it is not differentiable also at that point. Does it mean same or is it different? I mean,
no. See, for differentiability, actually you need continuity. Okay, so differentiability is actually one step further. Okay, first, if a function is not continuous, from there itself you can say that the function is not differentiable.
Okay.
And
so
if
it means okay.
And if a function is differentiable, okay, from there itself you can say that the function is continuous.
But here only we had one example for modulus x.
Can we say differentiability is
modulus x is
of
continuous at x is equal to 0, but
so
it is not differentiable at x is equal to 0.
that is what I said, right? If a function is continuous, okay, you can't say anything. Okay, if a function is not continuous, that is what I'm saying. If a function is not continuous, then you can say that this function is not differentiable. Okay. And if a function is differentiable, then you can say that this function is continuous.
Okay, so in what scenario it will be
is
continuous and not differentiable?
Let me write it. Differentiability implies continuity.
Correct.
Okay, implies this limit exists. Okay, so but the reverse implication is not. Okay.
Sir, but in what situation continuous but not differentiable? Can you give one example, please?
Continuous but not differentiable. This
like
is,
that mod x.
This is the example. Okay, this is continuous at x equal to 0, but it's not differentiable. Okay. You can check that this is
Okay, sir. Okay.
For continuity, the limit expression is different, and for differentiability, the limit expression is different.
Yeah, that is correct.
So do not confuse with that we are equating a limit for continuity and differentiability both, but they are
So in
different.
differentiability, we are calculating slope. So left side slope and right side slope is different. Is what we are arriving at.
Yeah, exactly.
Thank you.
So by
Thank you.
differentiability, we are actually checking whether the curve is smooth or not.
Yes,
Yeah,
correct. Absolutely
If
correct.
there is a right angle or some other angle, then it is not possible to be differentiable. That's what we are identifying, correct?
You are asking to me? Or?
If there is
No, sir. I'm just okay, sir. Thank you. I think I get the idea now. Thank you.
If we draw the graph of X mod, it will be clear, actually very clear, because there will be it will be pointed graph. So wherever there is a pointed graph, it is not differentiable, but it will be continuous. So that way.
Yeah.
Sorry, sir.
Okay. So, okay. Anything else you want me to discuss?
So can we say that linear function is always not differentiable?
Linear function is differentiable.
So graphically, we can't draw the tangent now.
Why? That linear function is itself a tangent to that linear function. Okay. A linear function is itself actually it's a tangent to that function. You don't have to actually find the tangent. That function itself is tangent to that function.
Okay, sir, got it.
Sir, since we're like talking about tangent.
Sir, if a function is differentiable at some points in a graph and it's not differentiable at some other points, then can we say that the function is differentiable?
No, it's depend. You can't say that the function is differentiable on the domain.
So, for example, if we take tan x, it is not differentiable at some points.
Yeah. So yeah, it's depend, right? So tan x is actually differentiable at all the points in the domain. Okay. So you are basically saying that there are some points
where the tan does not exist. Right?
Yeah, the function is not defined. If the function is not defined, then how you are going to check the differentiability at that point?
Right. Yeah.
So yeah.
Tangent.
So for example, if you see this function is differentiable so this function is differentiable at all the points in the domain except this 0. Okay. But so since this is not differentiable at 0, so therefore I can't say that this function is differentiable on R. That I can't say. Okay, this is not differentiable on R because I have one point on R on which this function is not differentiable. So you have to be very specific when I'm saying this function is differentiable on a set S, right? That means the function is differentiable at all the points on this set S. Yeah, anything else?
Sir, if you have a wave function.
Wave function.
Yeah, like any wave function.
Sin x.
Yeah, sin x or cos x. When can you say that there's a unique tangent at a particular point?
Wave function is always differentiable.
Okay, so there's a unique tangent.
Yes.
Okay.
So if the function is differentiable at that point, okay, in that case you will have a unique tangent. So the problem with what this, if you draw this mod of x, okay, so the problem is actually you don't have a unique tangent at this point 0, 0.
Yeah.
Okay, this is a tangent. Okay, this is a tangent, and this is also a tangent. You have actually two tangents. So that's why your right hand limit is right hand derivative is 1, which is precisely the slope of this line, and your left hand derivative is -1, which is precisely the slope of this. Okay.
6.
So yeah, so I am not going to do, so again, like I certainly I can't discuss all the concept. Okay, so probably I am not going to discuss almost everything about Riemann.
So can we move to integration then?
Yeah, I can.
That's something that we all these concepts actually are pretty detailed in the video. So, but integration is something that I think a lot of us are looking for.
Yeah, if you want, I can basically I can move to integration. Okay.
Yes.
Yeah.
Hospital's rule.
Sorry,
Hospital's rule. Can you give it to you?
I can't hear you.
Hospital's rule. Can you explain that for a few seconds?
It's talking about L'Hopital.
Yeah. Yeah. Hospital.
Yeah.
So just discuss small topics, just like a linear approximation and an hospital rule, and not
See, the
not
thing
for
is,
differentiation.
again, like I was going step by step. So if you, so again, like someone said Riemann sum, then again you are coming back, you are saying linear
No,
approximation.
if you follow this kind of methodology, then you can easily able to go to the integration
I
part.
guess I was following this method, right?
Yes, sir. Yes, sir. So
Yes, sir.
kindly continue, sir. Yes.
So again, like the problem is again, like certainly probably I can't. Okay, so you are maybe in some sense you are correct, because still there are few things probably I don't know whether I can cover this local maxima and minimum. So okay, let me start with L hospital rule. Okay, so once I'll discuss this L hospital rule, then probably I'll move to integration, and after that I can explain your doubts if you have some. So what is this rule? Can one of you tell me what is this rule?
Differentiating numerator and denominator until indeterminate form doesn't remove.
When the function is in 0 by 0 or infinity by infinity form, then we apply this rule.
Correct. So suppose you have this thing f of x by g of x, okay, right? And suppose this is in 0 by 0 form, okay. If x is as x tends to a, this f of x is going towards 0 and g of x is going towards 0. If this is in this form, or this is in infinite form, then if limit f dash x g dash x exists, if this is exists, then my initial limit is nothing but this one, okay. F of x by g of x is nothing but limit x tends to a f dash x by g dash x, okay. So this is how this is precisely the method of L hospital rule. So let me, so one of the obvious example of this L hospital rule is precisely this function. Maybe you know, almost all of you know this function, right? So consider this function, okay. So this is, let's say, 0, and this is if x is not equal to 0, and this is 0, right? So now I want to check the limit of this function at x equal to 0, right? So this function is in what? This function is in 0 by
0. 0 by 0 form.
0 by 0.
Right. So now if I take the derivative, x tends to 0.
Minus cos x by 1.
So cos x by 1, this is precisely 1, right? So this limit exists, right? So this limit now exists. Since this limit exists, then I can say that this my initial limit is nothing but this limit. This is 1. Okay, so this is the obvious example. And I guess any other question you want me to discuss? Probably some question was there.
Sir, if it is x raised to 5,
you are talking about the quiz paper. Quiz question, right? You are talking about the quiz 2 question, right?
No, yes, quiz 2 question.
Yeah, tell me that question. And probably this question was something like this.
It was limit extending to 0 of sine raised to 5 of x.
Sine 5 of x.
X upon sine x raised to 5.
X raised to 5, right? So this whatever it is just a application of this one. Okay, this is a application of this thing. Okay, so what you can do here, so you can write this thing, limit extends to 0, sine 5 power x by x power 5 times x power 5 by sine x5. Fine. Okay. So what I can do now, I can rewrite this thing, limit extends to 0, sine x by x power 5. Correct?
Yes.
Now what I can do now, correct?
Yes.
So one thing
limits are 1.
So this is more or less clear that this is 1,
yes,
right?
This is 1 and multiplied by 1.
And this is also 1.
Yes.
Okay, so what you can do, instead of x5, you can write this x5 as y. Okay, let's say y equal to x5. Then this is nothing but limit y tends to 0, y by sine. Okay, which is 1. Right. So eventually what you are getting 1. Okay. So as I said, this is just application of this sine x by x. Okay. Clear?
Yes.
Okay. Any other problem you want me to discuss related to L'Hopital rule?
Sir, can we solve this question with L'Hopital rule?
Sorry?
Is there any ways to solve it with L'Hopital rule? This question.
I have solved using L'Hopital rule, right?
So you do some adjustment over here. No?
Yeah. So again, like you have to do again, like
I'm asking just because L'Hopital rule is more easier.
Probably you can do. Probably you have to differentiate this function maybe bunch of times. I'm not sure. So this is, I differentiate this.
I think sine x by x is very standard limit. Limit x tending to 0, sine x by x must be learned by everyone.
So this is 0 by 0 form. Okay, so this is not a problem, right?
Yeah, but it is standard limit, no, sir.
Which one?
Sine x by x tending to 0, it is 1.
Yeah, this is standard. Like, see what actually he is saying. Whether so, what actually I have done, I have so in some sense I have multiplied this x5 and divided by this x5, right? So what, I don't know what he wants. I guess he is saying that okay, I don't want to do all this thing. Instead of that, I directly I want to apply this L'Hopital rule to this.
That's what I say. No, I means he said that L'Hopital he finds EG. That's what I say, that this is the rule we should learn. That will be more easier.
Okay,
sine x by x is equal to 1.
Yeah, that is actually easier, but again, like so he's saying, yeah, that I understand, but he's saying whether we can do it directly by L'Hospital. So actually, if you differentiate it, probably you need to differentiate it multiple times. Okay, so when if you differentiate it, what you will get this
Sir,
way?
it will be complex. We need to adjust. It will become product form.
So if for the
denominators.
first time, actually it will be in product form. Okay, then there will be summation as well. Okay, so yeah, so probably it will be little complicated if you
Okay, sir, no problem, no problem. You can go further.
Okay. Okay, any other thing you want me to discuss related to this L'Hopital rule?
So what all are the standard limit that we should learn for the examination?
For the
like sin x by x, tan x by x.
For examination, whatever things are there in your assignment, if you learn all these things, that will be enough.
So there is no need to learn formulas.
Graded assignment.
Okay, so the thing is, actually you don't need to learn the formula, but few things actually you need to remember. See, if you say that I don't want to remember the derivative of sin x, okay, then actually you are in trouble. Okay, so I'm not saying that you need to remember a lot of things, but there are few things actually you need to remember. For example, yeah, so derivative of sin x is cos x, derivative of cos x is minus sin x.
Minus sin x.
Derivative of x is 1. So if you try to compute it in the exam, then it will take time, right? So you can't solve if you don't remember. So you have to remember something. Okay, it's not that you can't. You can do everything without remembering. So you can't. Certainly you can do if you are in your home. Okay, you have enough time and you can compute everything by using the definition. And also you have to remember the definition as well. So yeah.
Formulas are provided in the exams or not?
No, it's depend. If it is a slightly complicated thing, then probably will provide you the formula. But if it is something like derivative of sin x, you need just derivative of sin x, maybe tan x, maybe cos x. Then certainly we are not going to provide.
Okay, sir.
Sir, actually, I want to ask. I have written many derivatives in my table, but I have confusion in two ones. Derivative of cot x, is it minus cos x square x?
Derivative of
cot x. Cot. Is it minus cos x square x?
Again, like as you said, I really don't remember what is the derivative of cot x.
Yes, sir, but it's correct.
Yes, sir, it is minus cos x square.
Yes, sir, it is minus cos x square x.
So first is what is cot x? What is cot x? How you can
cot x is cos x upon sin x.
Cos x upon sin x, right?
Yes.
So the thing is, now I know the derivative of cos x and sin x. Okay, so if I have to verify this, I'll try to do in this way. Okay, so the thing is, actually I don't remember the derivative of cot x because I have not in some sense I have not used it for maybe last 10 years. Okay, so but you have to remember that, okay, because you have to give the exam.
Yes. And if anyone can tell me what is the derivative of cosec x, I just want to confirm. Is it minus cosec cot?
Minus cosec x cot x.
Minus cosec x cot x.
Thank you so much.
Actually, every C function will have a minus for trigonometry. For derivative of every C function will be minus, means cos, cot, and what is one more C? Cos. For cos x, there is minus.
Okay.
Minus sin x, yeah.
Thank you so much.
Okay, just a minute. Let me. So some I don't know. Someone is saying for the long time he's saying that discuss this Riemann sum. Okay, I don't know why. So
Roshan.
Yeah, probably. Who I don't know the name.
What happened?
Yeah. So okay. So let me now go to this Riemann sum. Okay. So again, like I am not going into the details. Okay, so basically what I'll do now, okay, I'll just tell you how to compute this left hand Riemann sum, right hand Riemann sum. Okay, and then the last thing what I'm going to do, I'm just going to solve some question related to integration by parts. Okay, that is what next I'll do. Okay, in this session. Okay, so
sir, let's move.
Okay, so again, like I'm not going into the theory. Okay, so I'm simply pick some question and I will compute the Riemann sum, and there is, so again, this computing this left Riemann sum and the right Riemann sum, it's pretty straightforward. Okay, you can do for any function. It's really easy. Okay,
So can we ask question from mock?
I'll give you time. Okay, so I am here. Okay, so don't worry. Okay, if you are in this session, then definitely you can ask. Okay.
Yeah,
so,
I'm there.
So okay, so probably I will not take much time. Okay, maybe I'll finish everything in 15-20 minutes, because there are this left Riemann sum and right Riemann sum is more or less easy. Okay, so what you okay, so first what I want to find the left Riemann sum. Okay, so you consider this function. Okay, you consider this function x plus x square. Okay, so you consider the function on this interval, let's say 2 to 8. Okay, and the question is what? The question is approximate the integration of this function. Okay, approximate the integration of this function. Okay, using the left Riemann sum by taking 3 subintervals of equal length. Okay. Oh, I made this is a completely, yeah. Okay. So I want to approximate this integral. Again, I'm not going to find this integral. Okay. If you want to find this integral, then basically you have to integrate this function. Okay. You have to integrate this function. Okay. But I don't want to find this. I want to approximate. Okay. I want to approximate using this left Riemann sum. Okay. By taking 3 subinterval of equal length. Okay. So then what will be the first question is, what will be the length of each subinterval?
The first
2 to 4, 4 to 6, 6 to 8.
So what actually we are doing? We are
units per.
Yeah, we are making.
First interval will be between 2 and 4.
Just a minute. Yeah. I got it.
4 to 6 and third will be 6 to 8.
Yes, you got it correct. Yeah, got it. So just let me explain. So what we want 3 subinterval of equal length. Okay, so to get the length of each interval, what we need to do first, we need to find the length of this interval. Okay, length of this interval, and this length of this interval is 6, right? And what we want 3 subinterval of equal length. So for that, what we need to do, we need to divide this 6 divided by 3. So this
b
is
minus 8 by n.
2. Okay, so the length of each subinterval is 2. Okay, so now if I partition this original interval into 3 subinterval of length 2, then what I will get? The first interval will be 2, 4, right? Because I just need to add 2 plus 2, because length of my each interval is 2. Then the next interval is 4 and 6, and next interval is 6, 8.
Inclusive.
Right. Clear? So
all
next,
intervals are inclusive.
yes. So it doesn't matter actually, this in some sense actually. Okay, so I this area, in some sense it doesn't matter if you include that point and if you exclude that point. It's not going to affect your area. So
thank you.
Okay, so what I want to do, I want to find the left Riemann sum. Okay, so for the left Riemann sum, what I need to do, I need to take the functional value of the left side of this interval. Okay, I need to take the functional value of the left side of the interval, and I need to multiply with the length of the interval. Okay, that is the only thing you have to remember. Okay, for the left side interval, you need to take the for left Riemann sum, you need to take the left side of the interval. Okay, so first what I need to do, so I need to take this f of 2, right, times the length of this interval. What is the length of this interval? This is 2, right? And I have to do the same thing for all this subinterval. Second thing, what I need to do, f of 4 times what?
It's into 2.
2. And similarly,
F of 6 into 2.
Yeah, into 2. So now this whole thing is my left Riemann sum. So what is f of 2 here? F of 2 is basically 2 plus 2 square, right? This
Yes,
is 4 plus 6, which is, so this is 6 times 2, which is 12. And
No.
this is,
Yes.
yeah, I guess correct. 4 square plus 16 plus 4, 18 into 2, which is 36, right? This is 6 square plus 6, 42. Yeah,
No, I think f of 4 will be 40.
F of
Sorry, the second term will be f of 4 will be 20 into 2, I think. Because it is x plus x square. No?
Yes, 4 square plus 4, 20.
20 into 2.
Yeah, correct.
The first term will be 6, sir.
This is, you are saying 6.
2 plus 4.
What is f of 2?
F of 2 will be 2 into 2 plus 4.
Is 6, right? What is 6 times 2?
6 into 2 will be 12, right?
Yes, so that is what I have written.
That is why it is 12.
Yeah. So this is 12, this is 20, this is 82. Okay, so the final result will give you
The second one will be 40. 20 into 2, 40.
20 into 2. Yes, my bad.
And instead
84.
of 82, I think it should be 84.
This is 42 plus 2, right? 84.
42.
84.
84, 42 into 2. 84, yes.
So, yeah, so you can add these two numbers, and the final result is actually your
136.
Yeah, 136 is your left hand Riemann sum. Okay. Okay, so yeah, so
Also, if we have to take a right Riemann sum, we have to take a right side of subinterval and the length.
For example, let's say you want to find, suppose you want to find the right hand Riemann sum. Okay, for the same thing. Okay.
Right.
So suppose you want to find the right hand Riemann sum for the same thing. Okay, so now you have so now what you need to do, you need to take the value of the function at the right side of this of each interval. That is 4, that is 6,
8.
that is 8. Okay, so this is f of 4 times length of the interval, which is 2, plus f of 6 times the length of the interval, which is 2, plus f of 8 times the length of the interval, which is 2. So this is your right hand Riemann sum, and the left hand Riemann sum is f of 2 times 2 plus f of 4 times 2 plus f of 6 times 2. This is your left hand Riemann sum. Okay, so there is something called middle Riemann sum. Okay, this middle Riemann sum. So for that, right hand Riemann sum, left hand Riemann sum. Okay, I should write right hand Riemann sum, middle Riemann sum. So can you guess now what will be the middle Riemann sum?
F of
I think
3.
average.
F of 3 into 2.
F of 7.
So you need to take the middle point of this interval.
Yes.
Okay, so
4
this
plus
is
2 by 2.
yeah, this is 3 f of 3 times 2, 6 plus 4 5. This is basically f of 5
F of
times
5.
F of 5.
Then F of 7.
7 into 2.
Yeah, so again, like this is the overall idea for this Riemann sum. Then okay, so this is more or less straight forward for you to find this Riemann sum. And okay, so let me tell you, if there will be
So can I ask you one question regarding the activity? This related to Riemann sum only. 9.4 question number 8.
Yeah, I'll come to that. Okay, just let me finish. I'll just discuss one more thing. Okay, maybe this integration by parts. Okay.
In this middle sum, if there are even number of terms in the interval that we took, then we have to add the middle 2 terms and divide it by 2. Is it like that, or
in an interval you have
even number of terms? Even instead of odd number of terms, if we have even number of terms,
what
then
do you mean
what we
even number of terms?
So in this interval we have 2, 3, 4, right?
Sorry.
In the first interval we have 2, 3, 4.
No, in the first interval, the interval is 2, 4. That's all. We don't have anything. The interval is 2 closed, 4 closed. That is my interval. There is nothing 3 over here. 3 is inside that. Okay. For the right middle Riemann sum, I need to take the middle point of this interval. And what is the middle point of this interval? This is precisely 4 plus 2 by 3, which is 4 plus 2 by 2, which is 3.
So suppose my interval is 0 to 5, 5 to 10, 10 to 15, then I can take 2.5 like that.
0 to 5, 5 to 10. Yeah, 10. Then take the middle point. This is 5 by 2.
That's 2.5.
So then 5 by 2 times the length of the
not same, no, in all the cases.
Sorry, can you repeat?
The sum is not same in all the 3 cases.
No, if you change the interval, then yeah. So you are saying this one and this one and this one, right?
Yes.
Yeah, since the sum are not different, that's why you have 3 different names, right? Otherwise, if they will give you the same thing, then what is the point of naming three different things? See, that you are basically what actually you are doing. That is, if you read the question, actually, you are approximating this integration, right? So if you use this left hand Riemann sum, you will get this value. Okay, this value. So this is a approximation to this integral using your left hand Riemann sum. Okay, so this is a approximation to this integral by using right hand Riemann sum, and this is a approximation to the integral by using middle Riemann sum. Okay.
And sir, if you get infinite sub interval, then it will be same, right?
Infinite actually you can't actually get infinite. You can get, okay, so but that is slightly complicated. Yeah, same thing.
And sir, little bit there is confusion regarding notation. So we in course it is said we have to choose a xi star. So this left hand, this 2 is this
no,
2.
No, that xi star actually that is basically your. That is actually your Riemann sum. Okay, there is no left hand Riemann sum, right hand Riemann sum there. If you choose a xi star, then that is a Riemann sum. Okay, so right hand Riemann sum, left hand Riemann sum, middle hand Riemann sum, they are slightly different from this Riemann sum. These are actually the particular particular cases of Riemann sum. Okay, particular cases of Riemann sum.
Okay, so these terminology are not defined here.
So when you are saying xi star, right? You are choosing xi star, right? From this interval. This xi star can be arbitrary. So here actually we are choosing for this right hand Riemann sum, we are choosing this xi star to be to be the right hand side of this interval. Okay.
Okay, and for middle we are choosing the middle one.
Yeah. So
and what is norm of P here?
What is norm of P? What is the definition of norm of P?
There is in course in lecture they have defined a 2 mod symbol, and under that there is P.
Now there is a definition, right? Don't I'm asking of the definition. Those you simply don't read that symbol. Okay, what is basically the norm of a partition? You are basically asking what is the norm of a partition.
That is maximum value of delta xi.
Yeah, so you compute length of all this interval and you take the maximum value. The length of this interval is what? Length of this interval is what? 2. Length of this interval is what? 2. Length of this interval is 2. If you take the maximum, what you will get?
Sir, but I am little confused because every time we take equal interval, then why we are so equal interval means every time the
no, we don't take not every time we take equal interval. Mostly for this, when we are computing this left Riemann sum and right Riemann sum, at that time actually we take interval of subinterval of equal length. Okay, so actually it will be easier for you to compute. Okay, that's why. Okay, otherwise you can take some very bad subintervals. Okay, in that case you will face difficulty. That is the thing. Okay. So you can, if you take some interval like this 1, if you take 1 3, then 3 4 4 7 7 100 some 10 to the power 10. Okay, you can take interval like this. Okay, so then again you have to apply the same rule. When if you compute the left Riemann sum, okay, suppose you have a function like this. Let's say whatever this function, it's a function from 1 by 10 power 10 to r. Suppose you want to compute the left Riemann sum of this function with respect to this intervals. Okay, sub intervals. Then you have to do the same thing, right? What you need to do? F of 1, what will be the left hand Riemann sum?
Times 2.
Times the length of this interval, 2, right?
Yes, sir.
Then f of 3 times the length of this interval. What is that? 1. You similarly keep going. Okay. So there is nothing special about. See, as I said, it's if I give you something like this, then it will be easier for you to compute all the sub intervals. Okay. That's all actually. That's why we are giving you in the exam. We are mostly will give you like this, so that it will be easier for you to compute all the sub intervals.
Excuse me, sir. Sir, in few of the question, they asked to find the Riemann sum with limit of n when n tends to infinity. So in those questions, can we just integrate and find out the answers?
In yesterday's mock, this question 14 was there.
Yes. So I used integration in directly integrated the formula and got the answer.
Yeah, that's why actually we'll never ask you this type of question in exam, because we know that you can simply integrate it and you can get the answer. Okay, so but
thank you, sir.
Yeah, you can actually you can, but
they are supposed to integrate only, sir. There we cannot use the Riemann sum.
But here actually you can't simply integrate to get the answer.
Yeah, yes, in this we can't, because the answers
so
are
here it is specifically asked left Riemann sum.
Yeah.
So this is to be done in this way only. But in yesterday's mock, there was no specific
if there is
Riemann sum or right Riemann sum or middle Riemann sum.
So if nothing is given there, if nothing is given, then basically
Normal
Exactly.
integration.
Yes. You can apply the normal integration or whatever. You can apply this Riemann sum method.
Okay.
Riemann sum is tedious.
Not tedious. Okay, so because very few things are there in your course. Okay, so this is.
Sir, can you explain one sum of the trapezium rule?
This is just a tip of iceberg. Actually, Riemann sum is much more complicated than what you are studying. Okay. So.
If you're using Riemann sum and you have infinite subintervals, like n tends to infinity.
Sir, doubt session, sir, now. Over.
I just.
Sir, can you say how to determine those critical points and local minima from?
Yes, sir. Mark 9 question number 12 and 13.
Can you please explain saddle point?
12 and 13 Mark 9.
If d2y by dx2 is equals to 0.
Integration by part. So please start integration by part first. Sir, please explain saddle point.
Okay, so the next thing what basically I want to explain, this is precisely this integration by parts. This is the last thing I'm going to discuss. Okay. Again, I'll certainly take your questions. Don't worry about that. Okay, yes. Okay, so again, like this, more or less, you know almost everything. So this, okay, so basically what you do, suppose you have some function like this, u comma b dx. Okay, so this is nothing but u integration of b dx and minus u dash integration of b dx. Okay, and there is a specific way to choose this u and b. So I guess you know this. What is that? Islet. So choose u based on which of basically whoever comes first in this list, you have to take that function as your u, right?
The constant are considered to be algebraic, no? I want to.
Yes, but constant again. Why you want to take? If you have a constant, you can take it outside. Okay, why you will apply this integration by parts?
No, sometimes, for example, if we have questions some like that integral of log x dx, so that's why I'm asking.
Integration of, okay, yeah, you are correct. Yeah, in those cases you need it. Yeah. Sorry. Okay, so okay, let me take maybe some examples. Okay, so you take let's say you take this integration, let's say x cube log x dx. So can you tell me what is the suitable choice for u?
Log x.
Log is u and x cube is v.
So this is inverse function. L is logarithmic, A is algebraic, T is trigonometric, E is exponential. So as you can see, this log is coming first in this list, right? So this is coming first, right? So that's why you should choose your u as ln x, right? And what should be your v? V should be x cube, right? Okay, so now what we can do, we can apply this method, okay, whatever we have written above. So x cube ln x, so this is nothing but what? U. So this is ln of x times integration of x cube dx. Okay,
minus full integral
minus, then what is the derivative of
1 by x?
1 by x.
Integral of x cube
dx. Yeah, I should write one more dx, which I actually am ignoring. Okay. So what is this? This is ln x times x4 by 4, right? And this is nothing but 1 by x times x4 by 4 dx. And if I cancel them out, then what I will get? X cube by 4, right? So if I integrate it again, then what I will get? Ln x times x4 by 4 minus x, what is this?
4 by
x4 by
16.
16. And you will have a constant. Okay, so this is more or less the idea of let's say your integration by part. Again, like it's basically you need to choose this u and v wisely, so that you don't have to face any problem when you are applying this integration by part.
So can you repeat that islate? I wasn't. I'm not aware of that.
So this is actually represent all. This is inverse. This is basically inverse trigonometric function. Okay. See, this I represent. Okay. This L actually represent the logarithmic function. Okay. That means log x, log base 10 or log base c, it doesn't matter. So, and this A basically represent your algebraic function. For example, constant function or maybe say polynomial function. Okay. And this T represent trigonometric function. Okay. And E represent your exponential function. That means function like this, a power x. And actually you have to check, right? So if you see this thing, right? So if you see this ln x is what? Ln x is actually log, right? And what is this x cube? X cube is algebraic.
Algebraic. Okay.
So as you can see, this log is coming before a, right? This L is coming before a, right? So so that's why you should choose this ln x as your u. Okay. You should choose your ln x as your u.
Okay. Sure. Thank you.
Yeah. Okay. So now I can take your question.
Sir, activity 9.4, question number 8.
Yeah.
That remains some. How to find that?
Yeah. What actually you have done? Can you tell me?
Sir, I have taken in intervals 5 by n, then and then summation of that's going, and I'm not able to figure it out how to do.
No, that is what I'm saying. What actually what? Okay. So let me write. See, the thing is there are. So either you don't understand the question from the very beginning, or maybe you are not able to find the sum. Okay. So there are
Yes,
two possibilities.
yeah, I have understood the question, but I'm stuck in the middle by finding the sum. That's what.
Yeah. So yeah, just let me write. Okay. So, what is your function over here? Is this function? Function is f of x equal to x, right?
X, yeah.
This is your function,
equal
to x, and this basically defined on this interval, right?
0 to 5, yeah.
2, 5, and you have a partition, right?
Yeah, that 5 by n and 5 to n minus 1 that goes.
And yeah, so basically your xi is what?
5 by n.
I times 5 by n, right?
Yeah.
And so okay, so the first question is, okay, let's say first, maybe your first option. Anyway, I'm going to do only one option. If xi star is what? It's xi, right?
Yeah.
So in that case, what will be your Riemann sum, right?
Yeah, yeah.
So the Riemann sum for this is precisely what? Star.
Yeah.
Delta xi, right?
Yeah. I to 1 to n.
Yeah. So what is f of xi star?
F of x. So we put the values. If for first f of 0, then
what is xi? What is xi?
xi f of x.
Sorry, what is xi star? What is xi star?
X.
Xi, not x. I'm saying xi star is xi or not? It is given in the question, right? Then
Yeah,
what?
it's xi.
Then what
Yeah,
is
yeah.
fi? Then what is f of xi star? This is what? F of xi, right? What is f of xi?
I into 5 by n.
I into 5 by n. What is this del of xi?
5 by n.
Sorry?
I into 5 by n every time. 5 by n.
5 by n, right?
Yeah.
Now you find the sum. Now it's easy.
Okay.
So this is probably 1 to n. Okay.
N.
So then this 5 by n will come out 25 by n square.
Yeah.
Okay. And you have this thing. Now you try to find this
Okay,
value.
okay. Yeah, no. Thank you, sir. Yeah.
Yes.
Thank you.
Yeah. And next question.
Sir, integral x square 2 power 3x dx. Can you solve this?
Integral
x square
into
2 power 3x
2 power
3x dx.
3x
dx,
right?
Yeah.
Yeah. So what is your u here?
X square.
U is
x square.
X square. What is your b?
2 power 3x.
Dx. Now you apply this integration by parts.
I applied, but I'm getting so much big. And
sorry,
I'm not getting it. I have tried thrice actually. I didn't get that.
What is the integration of this?
A by ln
a raised to the power x upon log a.
3 ln 2.
No. What is the integration of this a power x?
ax log a.
ln
a raised to the power x upon log a.
What is the integration of this?
A power x.
A raised to power x divided by ln a.
Again, you are wasting your time. Just one person says.
Sir, a raised to the power x upon log a.
Ax power?
A raised to the power x upon log a.
Log a, right? So let me tell you how you will do it. Okay, so most likely why you are probably getting this wrong answer. So mostly, let me tell you again, like I'm not going to do it completely. So most likely, so if you start with, let's say x square 2 power 3x, okay, if you integrate by parts, okay, most likely you may get something like
recurring integral I am getting.
Then you bring this one to this side, right? You can add these two things and you can finally you have some a here, right? If you add this thing, then what you will get? 2 times x square 2 power 3x, right?
2 power 3x.
Which is a.
Yes.
And now what is your integration? Integration is nothing but this integration is nothing but a by 2. right?
Okay.
Yeah. That is what you need to do. Yes, yeah. Any other question from again, like from calculus part?
Sir, there are many integral formulas that they in integration. So, do we need to remember everything, or they will give us useful information in the starting?
In exam, actually, let me tell you, in exam you don't need much. Okay. So you basically need some x log x, something like that.
Which formula from which part, like isolate?
That you need to remember.
No, sir, I'm asking there are many formulas for integration.
Now you don't need this cot x, this cosec x, all these things you don't need. Okay, let me tell you don't need all these things for the ends and
Okay.
So I had a similar questions in what is the limit of the formula we have to remember, like in each category of isolate?
Sorry, I didn't get your question.
Like inverse formulae and the log. Okay, yes. But
No, as I said, right, I will not ask you this complicated question. Okay, this inverse and all these things. Okay, we just want to ensure that you understand this integration by part properly. So we'll give you some few easy examples in which you can apply that.
Okay.
Also, if you are getting difficulty in understanding it, so we can hit and trial, means first we can consider one function as u and solve.
Yeah. Again, like yeah, you can do that. Again, it will take your time. So
Yeah,
it's
only means two step will be enough.
Yeah.
Facing difficulty.
Sir.
Yes. Hello.
Sir, ask?
Yes, please.
Sir, this is regarding maxima and minima. Mock 9, we had one question, sir.
Mock 9. So, okay, I don't know whether they
I
are.
am seeing only 3 local minima in restricted domain of -7 and -9.
Question number, can you repeat? Question number 9, right?
I mean, mock 9, question number 13.
13. The graph is given, right?
Yes, sir.
Okay, let me share this question. Let me share this.
I'm getting 3, which is one is to the left of y-axis 1.
You can see it, right?
Yes, sir.
So question number 12, the number of critical.
12 also I'm getting only, what is my answer? 7.
Your question is question number 13, right? Or
yes,
12?
12 and 13, sir. First is 13, next is 12.
Number of critical points in the restricted domain, -5 to 9, right?
Yes,
so
sir.
where is -5? This is your -5, right? And this is your 9, right?
Yes.
And -5 is excluded. So, okay, so then certainly this is a point, right? You can see my cursor? No.
Yes, sir, I'm seeing.
Okay. This is a point 1. Okay. This is a point 2. Okay. This is a point 3. Right. This is a point 4. This is a point 5.
One more local minima is there, sir, below that.
Yeah, this is a point 6. Okay.
Below that, the black dot is.
Just minute. Okay, I forgot what actually. Number of points for f of x as okay, local minima. Sorry.
No, that question is between 5 and 9. -5 and 9 is the
yes. Number of
points.
critical points in the restricted domain -5 to 9. Okay, -5 to 9, right? So critical point is basically the point at which the derivative doesn't exist or the derivative is 0, right?
Okay, sir.
So this 1, 2, 3, 4, 5, 6. Yeah, the answers. Is there anyone which I missed?
Sir, 8, sir.
Close
No,
the interval.
this is a point, right? 1. This is
2.
2. Yeah.
Yes.
This is 3.
There itself 4, sir. There itself 4.
No, this is the same point, right?
Yes, I'm saying little bit. If you move, there is a minima, local minima.
Okay, okay. This is okay. Yeah, correct. So 1, 2, 3, 4. Correct.
Local maxima 5.
5.
And
6,
there itself
6.
local minima. Again one local minima. Again one local minima.
No, I'm computing
Sir,
critical
there.
points, right?
Yes, sir. In
Just-
critical points
okay,
also we should count local minima and
Local
maximum.
minima points.
Just
Yeah.
okay, that I agree, but again, go one by one. Okay, I'm here. You are okay. So this is 1 point. I'm saying this is 2.
Yes.
This is 3. This is 4. Okay.
Yes.
This is 5.
5.
This is 6. Okay.
Sir, you are
This-
missing one local
Sir,
minima there.
missing one.
The
Minus
black
5, comma
Yeah,
6.
correct,
also
correct,
Yes,
correct,
sir.
correct.
The
Yes,
black
yes.
points are critical, but
Yes,
the blank circles are not.
No, you are absolutely correct. You are
Yes,
absolutely correct. So again, like let me say basically whatever he said. So this is a point 1. Okay.
No, that is 2. We
Okay.
start from minus 5.
Please, madam, let me complete. Okay, minus 5 is, madam, not included in the domain.
It is not included.
So we have to, this minus 5 is not in the domain. If you see the domain, actually it's written minus 5 open interval. Okay. So this is my first point. This is my second point. This is my third point. This is my fourth point. This is my fifth point. This is my sixth point. Okay. This is my seventh point. And this is my eighth point.
Yes.
So 8 will be the answer.
Yeah.
Okay, sir. This 38 is okay. 13.
Yeah.
4. 8 is the answer.
So 13 is saying number of points where f of x has local minima in the restricted domain -7 to 9.
Yeah.
Okay. Local minima. Minus the domain -7 to 9.
7 to 9 included interval.
So certainly this is not a local minima. Okay.
Yeah.
Yes.
This is a local minima. 1.
Sir, how that is
Sir, why?
Sir, why? That is very sharp, no, sir. How can it be minima?
Sir, there actually we won't get what derivative equal to 0.
But you don't need, like, see that if derivative is 0, from there you can differentiate and get using that formula.
Sir,
but
according to definition, we have said that
no,
if derivative is 0,
no, what is the definition? Tell me, what is the definition of local minimum?
Where yes, actually it is local minima, right, sir? Where increasing to decreasing, if trend changes, it is called local minima or maxima.
So if you see this okay, let me go to, so if you take this graph, okay, if you take this graph, okay, sorry, again, like I guess, see that is a method to find the local minimum. So again, and if at a point the function is not differentiable, you have to check it separately. Okay, that is, Sarang sir has mentioned it properly as far as I remember. So if you take this graph, so in this interval, if you take this interval, let's say this interval, okay, in this interval, this is the function attains its minimum value at this point, right? That's why this is a local minimum. Okay, that is the definition of local minimum, right?
Okay.
1, 2, 3, 4, 5.
Okay, so then now you can get, right?
Yeah, now we are getting. We missed on that -6, -5, -6. We did not take.
Yeah, so that is what I am saying. See,
sir,
don't think that if function is not differentiable, then don't think that if you will not get any local minimum. Okay, you may get a local minimum, but you can't apply that method that you know. Okay. So you
sir,
can't
what about discontinuity?
Discontinuity in the whole domain, or you are saying?
Like if you see in that graph, from certain point it is increasing, and there is a discontinuity and there is a drop. So will we say that as a local minima or maxima, or we neglect those points?
Which one?
Sir, if you see in the quadrant,
are you talking about this
Sir,
one?
10, sir, sir, at 10, sir, at
yes,
10, sir.
at exact that point, sir, where you cursor.
10, I guess the function is not defined at 10, right?
Sir, no, sir, in quadrant 4,
Here.
yes, that one.
Here, right? So
yes.
No, if you choose a interval, okay, if you choose a interval here, okay, do you think any interval, you choose any interval, so do you think this point will be the minimum value in that interval? You have something like this, right? You have something like this, right? Correct or not? You have something like this or not?
Yes, yes.
Now, if I choose any small interval, okay, do you think this will be the minimum value? This will be the minimum value in this interval? No, right? Because you have bunch of values below that point, right?
Yes.
Yeah, so that is how you should actually. That is actually the definition of local minima. Okay, you have a h, okay, such that this f of x, sorry, f of, if a is a so a belongs to x minus h and x plus h, so that f of a is less than f of, let's say, b for all b in this interval. Okay, so now if you it doesn't matter if you choose even a smaller interval, also that is not possible. You will always get some value which is less than, which are less than this number.
Sir, one more small question in the same graph. If the global minimum does not exist, can we take the next minimum, sir? Like in this, that -10, it is not defined. So global minimum is not, it does not exist. That is the answer they have given. But
global minima, right?
Global minima.
Global minima doesn't exist because I guess
-6 as local minima. I mean global minima.
-10.
-5, -6.
No. Here global minima doesn't exist, right? Because see, this is an asymptote. Okay, if you see, this is actually asymptote. It's going towards -infinity.
Okay, so does not exist. Okay, sir.
Yes.
Okay, thank you.
Okay, anything else?
Yes, sir. I have a question.
It's I don't. Okay, sorry, I can't follow any particular order. Okay, maybe let me start with Soyan. So yeah, Soyan, what is your doubt?
Sir, I have a question from previous year question. I mean, if at least you just guide me how to solve it, so I can tell you the question.
Yeah, just tell me the question.
Okay, so sir, integration -infinity to infinity is to -x square.
Sorry.
E raised to -x square dx is equals to root pi, root over of pi.
Root over of pi.
Yeah, this is given. And another condition is given, integration -infinity to infinity.
Sorry?
Again, sir, integration -infinity to infinity. It's another statement. X square into e raised to -x square. X square into x square into e raised to -x square dx is equals to k into root pi.
K into
root pi. Root pi, sir, pi.
Yeah, sorry.
Yeah. So what could be the value of k?
So this is given, right?
Yes, sir.
So now you try to find this one. So
Okay.
So what is your u here? What is your u here?
I mean, sir, for the right hand side or for the left hand side? What are you
Yeah, for the right.
asking?
Okay, please.
U
Okay,
equal to x square.
I don't know from whom I'm getting, but a lot of noise. So for this one, I'm
Sir,
talking.
it was x square, sir. X square, sir.
This is
It was
XX.
x square.
Yeah, fine.
Yeah,
No problem.
yeah.
Yeah, actually,
Okay,
you try to do it actually. So for example, what actually you will get, okay, you will get some x maybe some power of x, okay, times e power minus x square, okay. So you can actually, when you will take the limit, actually you can substitute here minus square root of pi.
Okay.
Root pi.
Okay.
Yeah. So again, you simply you just ignore this infinity. First, you try to do this by parts.
The infinite integral.
Yeah. So no, you first try. Yeah, first you try to find this indefinite integral. Okay. You see where you whenever you are getting this expression. Okay. Whenever you are getting this expression, you can so when you will take this minus infinity to infinity, you can actually always replace with this square root of pi.
Oh, with the root pi. Okay.
Yeah.
Okay, sir. Got it, sir.
Yeah.
Sir, can we use here the property minus a by a to a fx
That you are saying this even function property?
Yes, sir.
Yeah, that you can use actually. Again, this won't help you much. Okay. So ultimately you have to do the integration. So it again, like you can do that, but if it is a odd function, in some sense it will help you much, but if it is a even, it won't help you much.
Is it 0, the value of k? Can you please tell?
I don't know. You have to do
it's
it.
0.5
No,
actually.
sign.
0.5.
Sorry?
0.5.
0.5. Okay.
0.5. Yeah.
Okay, thank you.
You have to do it again. I said it's not difficult. Okay, so this finding this integration is actually difficult. Finding this integration is actually difficult, so that's why it is given. Okay, but finding this integration again, you can't find the integration. You have to, whenever you are getting this term, so you will get lot of maybe two terms like this. Okay, in these places you have to replace square root. Any question? Okay, so let me check.
Yes,
Sita
sir.
Sharma.
Yes, sir. I have a question from quiz 2.
Question. Yeah. Ask.
So there was a question on subsequence. I was not able to understand why the option first was incorrect. Like it was there 5,7, 5,7, and Bn was 5 and when n is odd, and Bn was 7 when n is even. Why it is not a subsequence of an?
So an is what? An is
Yes,
1, 2, 3, 4, 5.
5, 6,
And
and
what
so
is your
on.
sequence Bn?
Vn is 5 when n is odd, and Vn is 7 when n is even.
So this is your sequence, right? Right? This is your Bn, right?
Yes, sir.
So if you see here, actually 5 is coming. So if you specifically, if you see this part, 5 is coming after 7, right?
Yes, sir.
So in your original sequence, do you think 5 is coming after 7?
No, sir.
So then how you can how then Bn can be a subsequence of A? See how you, so if Bn is actually, it's a subsequence of An, then actually you can get Bn. Okay, you can get Bn by deleting the terms of An. Okay, if you delete the terms of Bn, then you will never get Bn, right? Because of this, because here 5 is coming. So in your original sequence, 5 is coming before 7. But in your subsequence 5, if you consider this part, 5 is coming after 7. Okay, if I delete bunch of terms from An, then it will never give me Bn, right?
Yes, sir.
Yeah, so that's why Bn is not a subsequence of A.
Okay, sir. So one more thing, like, and there was a question that fx equal to 1 upon e to the power 1 by x plus 1. F is a bounded function on R, sir. How can we check for the boundedness?
I have discussed it. You can revisit. I as I said in the very beginning, this question was in quiz 2. I have discussed that question, pura complete whole question in quiz 2 revision session. Okay.
Like if it was not 1 upon e to the power 1 by x, then if for some other function, then how can we go for that, like check for that boundedness?
Yeah, then you have to specify me some function, right? Then only it's not a universal thing that I can apply everywhere. Okay. So it's depend. Like if you have some other function, then maybe it may be an unbounded function. So I can't prove that. Okay, it's depend on the function. See, the whatever tricks I am applying, I can't apply the same trick everywhere. It's depend on the situation. So I must have that kind of situation. Then only probably I can do.
Okay, sir. Thank you.
Yeah. Yeah, any
so one last thing, sir.
Yes.
So you said we gotta check equals to 1 point. So I just wanna know, like, how can we approach that kind of question? The mod thing that sir, the mod thing that you
I still okay. I don't know. You are not audible. Like you are asking that this question.
Hello?
Probably this question you are
yes,
saying.
Yes, sir. This one at x equals to 1, we need to find the differentiability. You said like we cannot say. So that one, sir. I want to know like how to approach that.
Just let me do it. This is okay. This let me find the derivative of this function. So the function is what? F of x is what? It's precisely x minus 3 modulus, right?
Yes, sir.
X minus 1 modulus divided by x minus 3, right? And
yes, sir.
What x is not equal to 3, right? And this is whatever
2, sir. 2. Yeah, that is something.
Maybe yeah, it's 2. Okay, it doesn't matter actually. If x equal to 3. Okay, you want to check the differentiability of the function at x equal to
1,
right? So
yeah.
Okay, let's go to the definition. Limit h tends to 0, right? F of 1 plus h, right? Minus
1 plus h. F of 1, yeah. F of 1 by h.
H, right? So what is this thing? What is
yes, sir.
What is 1 plus h? F of 1 plus h? Hello, what is f of 1 plus h? Can
I think my net is actually having issues. Yeah. So what would be like, well, wherever there are x, so we have to put 1 plus h actually.
So 1 plus h minus 1 divided by 1 plus h minus 3, right? So
yes, sir.
And what is f of 1? F of 1 is 2 times
2 times 1.
F of 1 is 0, right?
F of 1 0, yeah. 1 minus 1, 0, yeah, 0.
So the above what we have h minus
h into h
minus 2
mod,
yeah, then mod of h, right?
Yes, sir. Divided by h minus 2, I guess. Yeah, h minus 2 divided by
h minus 2 times 1 by h, right?
Yeah.
So now can you tell me, what do you think this limit exists?
No, because for less than, it would get I mean, it would take minus values, and for greater than 1, it would take positive values. So I think the limit would be minus 1 or something like that. I mean, they won't be equal.
Yes. So as you can see, as in some sense, as it tends to 0, okay. So you'll get one side, you will get -1, and another side you'll get 1. So this function is not differentiable at x equal to.
Okay. I mean, sir, regarding this question, so sir, if there is any arbitrary function like this, so if they are asking us for any different point, which is in the domain actually, let's say that point is in the domain, but it is like any other point apart from that point that we are examining. So that so we can just find just using like this logic, right? So any point we can
the
just.
Thing is, okay. So the problem actually, see.
So you can check for 5.
No, I will not check for 5. Okay, so this is not something funny that I will check for each and every real number. You should also do something, right? So the thing is, okay, so let me tell you the main idea. So what is actually happening here? Okay.
Yes,
so
sir.
what actually you are taking? Okay. So the problem is actually what you have. You are actually in the numerator, you have what? X minus 3, okay, and x minus 1.
Yes, sir. X minus 1.
So this is a parabola, right?
Yes, sir.
First, I try to draw. Let me draw the parabola first. Okay. So if I draw the parabola, then what I will get? This is 3. Sorry. Okay, my bad. This is.
So it would be 3 and 1. The 1 and 3.
Right. This is the, and this will be my parabola, right?
Yes, sir.
Right. But what what I'm doing here, I'm taking the modulus, right? I'm taking the modulus, correct or not?
Yes, sir.
So
Yes, sir. Yes, sir.
So the negative part will come to the positive side, right?
Yes, sir.
So what will happen now?
It's like that.
So it's clear from the picture, right? This is a corner point and this is a corner point.
Corner point. Yes, sir.
So mostly it will be non-differentiable at these points. Okay. So that is why I said that by this case, actually I said this function, there is a problem with at x equal to 1. Okay. And someone actually asked me, what about 5? Okay. Now you should tell me what will happen. So it's, if you see the graph now, then you should able to say what will happen at 5. It is basically,
yes, sir, 5 it is differentiable.
So the only problematic point is 1 and 3. Okay. So so the thing is, when you have a function like this, okay. So from directly, actually you can say actually this is not differentiable at 1 and 3. Okay?
1 and 3.
But when you have you have something on your denominator, right? So it's better to check it separately. Okay. So so when you have something like this, okay. So from here, actually you can directly say that it is not differentiable at x equal to 1. Okay, that you can say, because in the denominator you don't have x minus 1, right? So that's why actually you can say that this function is differentiable at x equal to, not differentiable at x equal to 1. But for 3, you need to check separately.
Oh, since we have x minus 3 in the denominator.
It's better to check. It's better to check separately. Okay, most likely it won't be differentiable. Okay, because it's more or less is something like this, mod x by s.
Got it.
So the graph which we counted for the critical points, I just need some clarification there.
Yeah. This graph you are saying, right?
No, sir. The one we counted the critical points, no? Previously.
Okay, so, yeah. Let me share it. Okay, you are talking about this one, right?
Yeah, the previous one. I think sometime back. This one. Yeah, that's right.
I guess this is the.
So, the first point which we had a doubt, no, I just want to have that clarification, because if we take a small interval around that point, where we have the discontinuity, no.
You are talking.
Previously, you were explaining that, no.
Yeah,
that point. If we consider for a say plus h around that point, on the left hand side we have some of the points which are above that value, right? Which have the value more than that point, right?
Yes, correct.
So will that be considered as maxima? I just want to confirm it.
No. For maxima means that point is basically it's the biggest thing in that interval. Okay.
Yeah, but when we are considering a point as a maxima, we just look into a small interval.
Yes.
In which it has a maximum value, right? So, but around this, only on that exact point.
Just a minute. Let me take this thing, whatever you are saying. So this is okay. Let me draw it properly. This is the point which you are not including.
Yeah, only that point I'm not convinced. Otherwise, fine.
Yeah, this is your graph, right? Somewhere, right? This is your
no, but this point, the point which we have in that graph, it's exactly below that, right?
No, the exactly below means actually I'm not. There is a thing. Okay, so okay, yeah, you are. Some sense you are correct. Let me draw. So let's say this is the point A. Okay, that means the value of this function at A is this. Okay.
Yes, the point which is below, right? Yeah.
So now so you are saying that A is local minima.
No, I think it's neither local nor minima because we couldn't conclude, because when we take a small interval around
it. That is what I said, right? So this is not so basically I didn't say that this is not a local maximum. I basically said that this is not a local minimum. Okay.
So we should not be counting it as a critical point then, right?
No, critical point is something different. Critical point is a point. Also, there are two things. Okay. So one thing is either it's a local maxima and minima. Okay. Not local maxima or minima. The derivative is 0. Okay.
Okay.
Derivative is 0. And the second condition is it's not differentiable. Okay. Point at this point, this function is not differentiable. Okay. That's why we are treating this as a critical.
Okay. Then it's fine. Okay.
Yeah, so we are only because of that one. So it's clear, right? This is not continuous also.
Yeah, this is fine. Yeah. Thank you so much, sir.
Yes. Okay, anything else? Anything else you want me to discuss?
Sir.
Yes.
Sir, let's say we have an interval for maximum and we are trying to, find the.
You are not audible, son. Just give me a few seconds. Just give me a few seconds. Yeah, son. What was your question? Yeah. Hello.
Sir, it's just a normal. Not any question. Question. I don't have any question. I just want to ask you this. Just the conceptual thing. Sir, let's say we have an interval, like any interval. Let's say closed interval A comma B. And we have like two critical points within the interval. So, sir, is it possible that like any 2 points, on the boundary points, is it possible that the values are pretty close, very close to each other when we find the maxima or minima at those, at those 4, on the 4 points?
Okay, so I still don't understand your question. Like you are saying, basically you have a function on this interval and this function has 2 critical points, right?
Yes, sir.
Yes. So then after that, can you repeat the last part?
Yes, sir. Yes, sir. After that, what I'm trying to say is like whenever we are calculating maxima and minima, so we have to calculate those critical points as well as those boundary points, right? And we can find the global maxima or whatever that could be. It does depend on the function as well. So we can like if we let's say we find the global maxima at point B. So that we should consider that as well. We should consider that, right? At B.
Yes.
Global maxima.
Yes. You see, whenever you are computing local maxima or global maxima, local minima or global minimum, okay, you have to always consider this endpoints, okay, or yeah, you always have to consider, you have to check your, so for example, let me take this example, let's say, okay, so if you take this example, okay, let's say this is your mod of x, right? Let's say this is on your interval -1 to 1, okay, so if you try to find the critical points, then actually you will get only one critical points, right?
Yeah, at 0. Yeah.
0, right? This is the critical points, and this is the local minima.
Yes,
right?
sir. Yeah.
And this is also a global minima because you don't have any other local minima. Okay, because
yes, sir.
Yeah, because what is the reason? Because if you check the EA points, what your boundary points, -1 and 1. So f of -1 and f of 1, they are greater than f of 0, right?
F of 0, yes, sir.
So 0, so it's 0 is certainly it's a local minima, and also from here it's clear that this is a global minima as well. Okay, and for local maxima, what you need to do, you need to consider this this boundary point. Since you don't have any local minima, okay, since you don't have any local maxima, okay, local maxima in the sense by finding the critical points, okay,
critical.
Yeah, so then you have to shift to your boundary points. First you need to check f of -1, then you need to check f of 1, and since both of them are giving you 1, okay, that means both of them are global
maxima,
global maxima, and as well as local maxima.
Okay. Local maxima. Okay. Yes, sir. That was my another question. I mean, can we have that? So yeah. Okay, sir. I got the answer. Okay, sir. Got it, sir.
See, global maxima is always a local maxima. Global minima is always a local minima, because global minima is what? It is the minimum among all the local minimums.
Right? Among all the exactly. Huh. Okay, sir. Got it, sir.
Okay. Okay, so then I'll stop.
Could you please clarify mock 9, question number 8, please?
Okay, fine, no problem. Mock. Is it from calculus?
Yeah, mock 9, 8th question. It might be easy, but I don't know how to solve it.
No problem. Let me check. Question number 9.
8. The A and B, that minimum value. Yeah, this.
Okay.
So here sign can take a maximum value 1 maybe.
Yes.
Is that right?
Correct.
Yes,
yeah. You are in right track. Then what?
So then it will be 10 square. Though I thought it will be 10 square, then 10. If we take the 2 into 5, then it will be 10. Is that right?
Yeah. So then what basically you will have? You will have 5 log 10, and this is
10
100.
square.
100.
Yeah, 10
right?
square.
So this
I'll have the value as 10 finally.
So then this is basically 10, and this is precisely 10, right? So A is 10.
Yes. For the B, I couldn't find actually.
So this is a parabola.
I mean, for B, that's a parabola, right?
Yeah, but I think after should we find that to find the minimum value, I should find the vertex and have the y value, right?
Yes, you need to find the minimum value of the parabola first.
Yeah, that's I found it as.
Okay,
I think only for me, the thing is, I get the minimum value as negative as for y value. That's where I got it out.
That is not a problem. Okay, let me check. Minimum value can be negative, but I don't know whether you have done it correctly or not. So this is log 10, 10x square. Can you tell me?
Minus 40x.
Minus 40x.
Then minus 45, I guess. I didn't see.
Minus 50.
Minus 50.
Minus
right?
50. Minus 50. Yeah.
So to get, so this is actually whatever this B is basically minimum of this, right? So you need to find the minimum value of this. So for that, you need to find the minimum value of the parabola. So what will be the minimum value of this parabola? This is 40 by 40 by 2. This is 2, right? So x equal to 2. Just stop me if I'm doing
40 by 20, right? A is 10.
40 by
B by 2 is
At 2, sir. At 20 is at 2.
A is 10.
Yeah, this is 2a, right? Minus
So
b
40 by 20, so fine, answer is 2.
Yeah, that is what I guess I have written. Okay, so no problem. So this is basically at this point, this parabola will give you the minimum value. So next you need to find the minimum value. So this is I guess 10 into 2 square, which is 40 minus
80 minus 50.
Minus 80 minus.
I get minus 90.
It is 10.
It's minus 90.
This
so
is
that
what?
was plus 50 or minus 50?
This is plus 50.
Plus 50.
Yeah.
Oh, that's where.
Yeah,
Okay,
it is
that's where I went wrong. Sorry.
Yeah.
Even then.
Okay, let me do
Yeah,
it.
yeah.
So
Okay, fine.
now you have 10, right? Now you have 10. So
Okay, that is 1. Fine.
So this is B is 1. Right?
Okay.
A is what?
Okay.
A is 10.
I copied it as minus 50. That's where I went wrong.
Then I guess everything is more or less correct, right? Like
Yeah,
now
yeah,
you
that's
can do it.
Yeah. Thank you so much.
Thanks. Okay. Okay, then yeah, I'll stop now.
Sir, when mock solution will release?
Mock solution, I have to ask Srikant. I don't know. Like I guess Srikant was preparing the solution. I have to ask him. Okay, maybe probably tomorrow I'll tell him to upload the solution.
Should we focus on the substitution also, integration by substitution?
No, that okay. So I should not answer this question, right?
Okay.
I doesn't think so, sir.
Sorry.
I doesn't think so, sir.
Yeah.
If you don't think so, then it's up to you. Like I don't have any.
So I think you are talking about now that x is equals to a sine theta and x is equals to a cos theta, these kind of thing. If you are talking about this thing, then I don't think so.
Okay, so like let me tell you, like whatever I have discussed today. Okay, so whatever concept actually I have discussed today. So in some sense, like all the questions of calculus are actually basically from all these concepts.
Okay, sir. Thank you.
But again, like the thing is, question are slightly different, not slightly, completely different. So that you have to understand the concept. Okay, fine. Okay, so yeah, okay, I'll stop the session now. Okay, good night.
Okay, sir. Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Good night,
Thank you, sir. Good night.
Yeah.
Good night.
Yeah, good night, sir. Thank you.
Thank you.
Have a nice good night.
Yes. Thank you. Good night to all.